Hello. All are requested to be seated. It's an absolute pleasure to have you here today at the third day of Indian Geotechnical Conference IGC 2024, Geotechnical Engineering for a Sustainable Tomorrow. I request Session Chair V.S. Chhatrapati, CECONS, and Dr. Shobha Cyrus, Professor in Civil Engineering, Principal School of Engineering, Science and Technology, to please take a seat on dais. Today's first keynote lecture is on failure of retrofit rectification of reinforced soil wall on Hill Road by Ms. Atasi Das. Please join me in welcoming Ms. Atasi Das to stage. Before starting the session, I would like to give brief introduction about Ms. Atasi Das. Engineer Atasi Das has graduated with Bachelor's in Civil Engineering from Jadavpur University, Kolkata in 1998 and consequently with her Master's with focus on Transportation and Geotechnics from University of Delaware, USA in 2001. After a brief stint of consulting experience at Tata Consultancy Engineering, Mumbai, after her post-graduation in US, she joined Ramil Clapper and Carl Consultancy Engineering in Maryland, USA as a geotechnical engineer and worked on the prestigious Woodrow Wilson Bridge project of Washington, D.C., worth $2 million and the highest value project in those days. In 2003, she moved to Maryland State Highway Administration, Baltimore, Maryland, USA, as pavement material geotechnical engineer and managed and supervised multi-lane state-wide highways, expressways, and interstates connecting Maryland, counting more than 20 projects. She served in USA for about 5 years and came back to serve motherland in 2006. Since then, she was worked in various organizations in the capacities of pavement geotechnical design consultant and PMC coordinator. Currently, she is heading the pavement material and geotechnics division at GR Infra Projects Limited in the capacity of Assistant Vice President, designing, managing, supervising construction and maintenance of countrywide 2-lane, 4-lane, 6-lane, 8-lane highways and expressways. She has been recognized with various awards and trophies in her portfolio. Third CE and CR Women Construction Empowerment Award in Engineering 2024, recognized as Distinguished Daughters of India Soil by Indian Geotechnical Society for her valuable contribution 2023. Awarded the prestigious 14th Vishwakarma Award for Innovator in 2023. Commendation certification from NHAI for her valuable contribution for the construction of longer life pavement in India 2023. Trophy for Best Project using New Technology at Bitumen and Bitumen Modification Conference 2021 by Bitumen India Forum 2021, New Delhi. Now I request Ms. Atasi Das, ma'am, to please start the lecture.
Good morning, everyone. And here we come, this is the morning session on keynote lecture on failure and retrofit rectification. As we know that a lot of infrastructure development is going on in the northeastern states of India and also Himachal Pradesh and Uttarakhand. But is it always that we are building and we are not facing problems? So this is one of the case studies that I present, which is the failure and how we did the retrofit rectification without building from, again, fresh anew, how to do that. Now, this is what the infrastructure infringement we are doing to the mother nature while we are widening from 2-lane to 4-lane in the highways and, constructing tunnels and also the greenfield highways with higher heights of cut slopes and all. Ideally, we should have some context-sensitive solution, like we should blend our infrastructure construction, but always it's not possible. Sometimes it becomes a concrete jungle while we are doing these slope stabilization measures or reinforced structures, but we still do our best. So the hurdles on the way are the inclement weather, rainfall, avalanches, snowfall, and then extreme temperatures. The working window, the construction working window is very less. So the lacune in construction remains, material availability is less. Sudden surprise landslides are there, safety concern is there. We have seen in the past 2 days how the early warning systems are, with the help of AI, are getting developed, and this helps. So this is the case study where, this is the perfect highway, like 2-lane carriageway, 2+2-lane carriageway we were having. Now, what happened is that one fine morning, due to heavy rainfall, this gave away. Let us concentrate on the RSW. The RSW section, which is the reinforced soil wall, and the reinforced soil wall is a section which is we can construct with a fascia of 80 degrees, and there is an interface, and then there is a RE wall section, and RE wall section is normally the panel fascia wall. So what happened is that this is the RSW post-collapse in 30 to 35 meter section. The entire carriageway went out, and this is what happened. Geosynthetic straps were hanging, geogrids were lying, and the top to bottom height, it is like 50 meters. It became a 50-meter gorge situation, and the mobility was completely stopped in the state of Himachal Pradesh. So this is the problem statement. I guess this is the pipe culverts and drainage systems. Everything was there, but still we face due to incessant rainfall, and these are the distresses that occurred in here. I will just skip the video. There were some unforeseen and unanticipated instances which caused the failure, which I will elaborate here. Here you see a dumped soil mass against the highway, and here in this picture you will be able to see the dumped soil mass, which is because the project has already gone into maintenance after construction. So getting dumping land in the hill roads, it's a very big problem. So what happened is that The maintenance team are not that technical. So whenever they excavated somewhere, they dumped against the RE wall and against the RS wall. What happened is during incessant rainfall, this dumped mass became a saturated mass, and it gave active pressure onto the retained fill and onto the reinforced fill. And water slowly seeped into it and developed heavy hydrostatic pressure, and that caused the failure. I mean, it is amazing. I mean, just for a little bit of lack of knowledge base, what happens due to this is what we saw. Field investigation works, a lot of the boreholes were done on the again, and it is what was found that it is called weathered rock, and so sound foundation was not able, and we can see from the rock cores that it is not sound rock at all. So how do we go about? The geological information is that it is in the zone, seismic zone 4, and it is all sandstone, highly jointed and shattered. And what are the strategies of the retrofit rectification? This is the layout plan. As we see, there were 3 sections. One section with the RE wall in panels, one section of the RSW, and which is like constructed with a face angle of 80 degree with stone fascia, and then the balance section, which all got disturbed and bulged and all. So how to rectify? And this is so 3 sections. The entire corridor of that 200-meter section was developed into 3 sections. The options considered were initially RSS having a slope limiting to 70 degree. That's when we call reinforced soil slope, and it is no more a wall but a slope. An RE wall to replace the REW shall be continue with the RE wall, or a viaduct with abutment support, or it would be shored mechanically stabilized earth wall, the SMSE wall. Now global stability and safety has to be ensured, because the road has to be maintained also, because the other two, the carriageway, was acting as a both-way carriageway now, and time of redesign and construction was the limitation given by the client, because the apple season was coming. We cannot keep the highway closed for an entire time. We were given just 4 to 5 months for the design and construction. Availability of land from forest won't be available, so limited ROW, and further excavation won't be possible because it will encroach into the running highway. Geotechnical foundation gave the view that there won't be sound foundation also, and proximity of the suitable fill material was also a constraint. This is the option 1. Again, as we saw, if we flatten the slope to 70 degree, that gives the safest option, but cutting of trees, additional forest land permission, huge quantum of quality backfill material, it was saying that time of construction would be 5 months, and 90 soil lifts with good compaction for a height of 22 meter, and building the foundation with step PCC wall, and building the again,
it was not a feasible option, as we saw. Then coming to the reinforced earth wall, continue the earth wall while coming inside a little bit, because that height or the retaining wall will be crucial also. Not getting a foundation, it will require a deep foundation, which was not feasible again. But we started building the foundation of the RE wall, and also the base panels were constructed and everything. But what happened is that in between rainfall happened, and again the profile got changed because the road was open and all water penetrated. So the height of the RE wall 18 meter with 2 tier, and the SBC requirement also was a crucial. We found only 20 ton meter square at that level, and the requirement was 48 ton per meter square. So we had to again give up this option also when it was.
Abutment support, again, this will be a safe option, but it also requires deep foundation, and also the time of construction will be close to a year, and we didn't have the time. And blending into the adjacent the system of RE wall and RSW will also be a difficult thing, maintaining the interfaces and all.
The option 4 came out to be the best, which is the shored mechanically stabilized earth wall. And I will come to it in detail because this is the option we adopted. Now, this is a little bit on the economics and the time of rebuild. The RSS, the REW, the RE wall, the viaduct, the shored MSME wall. We can see the cost versus time. The RE wall was the cheapest option, but it meant 6 months, but we started the construction, and the lacunae were found. And we know. So the costliest option came out to be the SMSC wall because it is at 10.7 crore, but the 4 months, and the other good points are no additional land required, less time required with respect to the other options, and no extra cutting required. So this is the option we selected. A little bit on the SMSE wall. It's a hybrid system, reinforced soil structure system with a sleek retention, and we can go to higher and higher heights. And it can be accommodated with the limited base because we can accommodate the base. The requirement is only 0.3 H. H is the mechanical height of the system. And whereas for the normal RE wall and the RSW, it is 0.7 H. And it is combination of in situ soil nail, and the load is transferred through the nails into the in situ weathered rock through frictional positive or mechanical connection, and reinforced soil is constructed connecting the reinforcement with the soil nail structure. So option 1 and 2, as I already explained, we could maintain the safe traffic also. Traffic movement was also ensured, and stabilization of the slope also will be less because, I mean, we have to stabilize the slope as we excavate further so that there is no endangering the running traffic won't happen. And so these are the elevation details. As I previously mentioned, we divided the section into 3 sections, 1, 2, and 3. And while we rebuilt the section 2 from the bottom, but the other sections were strengthened or jacketed. Rather, I would say jacketed. And these are the details that we followed. First of all, removal of the dumped mass. This is the one that triggered the failure. That removal has started. You can see from the picture, the first and foremost attempt. Actually, all works were started parallelly because otherwise doing a 44 months target would be very difficult. In the phase 1, it was dismantling of the top tier of the RE wall, which was like more than 16 meter in 2 tiers. We dismantled the top tier, strengthening of the bottom tier wall, and reconstruct the RE wall at the top with a stone fascia. Then in the portion 2, this is the section where we constructed completely, and nailing at this is the SMSE system, the nailing at the hill fascia, then filling with the back mesh, fixing the back mesh, laying of drain tubes because drainage is also a concern in these hill roads and we have to maintain the drainage, and laying of and then construct the RE wall with the stone fascia. Now coming to the portion 3. Portion 3, which involved the strengthening or jacketing of the bottom tier and reconstruction of the RE wall at top. So this is the system, the SMSE system, nailing to stabilize the existing earth wall, first tier, provide all kinds of drainage with the form of geocomposite, perforated pipes, geotextile, boulder gallery, and ensuring that there is no hamper in the drainage system. Then development of the additional valleys, the additional fascia. Now this is in picture step by step. This is the section in the one, that RE wall which has bulged. We had to remove it, and we can see the bottom tier. And here we nailed the bottom tier, and then we jacketed this bottom tier with a stone fascia wall. We can see the panels behind, but this is how we took care of the strengthen the bottom tier without building. It's a retrofit solution which followed. And now building the second tier on top of the jacketed bottom tier. This is what happened. And so this is the picture of the section 1, where we can see that the left side is what it was, and on the right side what it has become now. Now section 2. This is the one section we have we built in entirety. And these are the soil nailing into the excavated, the weathered rock section, and making the drainage provisions also. So now building the SMSE wall, there was an intense nailing done towards the bottom where we had the list width because we have to accommodate the load has to be transferred there, and then we built the reinforced wall with the stone fascia outside. This is a short video of the case that we had actually at site when we started the work. We can see some gabions at the bottom. Those gabions were used as a protective measure to protect the toe so that during construction no untoward incident happens and all. So that, and we left the gabions there. It was not necessary to remove the gabions. We let them be there where they are, and then we constructed from there. And so this is a snapshot, and when we started the construction, building the foundation from in the section 2. Now the nailings and shotcrete and nailings were done to strengthen the roadside, the existing carriageway that we were maintaining. Those were alongside strengthened as we started the work also. From many fronts we opened the work. So these are the nailing works going on. So this is the foundation has been prepared now, and we are slowly coming up, and we can see a whole lot of stuff on the existing carriageway side. There are meshes still, and then the geocomposites for the drainage part, because the interface of the new portion and the old portion is very important. The strap laying is there. And then there was day and night work, so that, because, I mean, to meet the timeline of 4 months, and it was extensive activity in the small section of 200 meter. The strap laying is going on, and the geocomposites are being placed. This is the subgrade top layer. We have come on top now. And so this is the finished wall that for the section which has collapsed, so we have rebuilt it now within a frame of 4 months. And now coming to the section 2, this is what it was before, and this is what it looks after now, after rebuilt. Now coming to the section 3 now, where we had like the stone fascia wall was there. So they were also nailed, because it was not a wise idea to remove everything, because that will destabilize the road, existing road. We were very close to the road now. And the thing is that we had done nailing in 3 instances now. One was nailing through the RE panels, one was nailing into the in situ rock, the weathered rock, and one was nailing through the stone fascia, the RS wall. So there were 3 schemes of nailing which were done. And so this is the jacketed, and then after the nailing was done, so this was jacketed with a stone fascia wall again, and nothing was removed, but the jacketing was done. So the mesh fixing on the top tier is going on, and this is the strengthening of the existing RSS, the stone fascia, as we see, what it was before and what it has become now. See, and that will provide, and some accessory protection schemes were done in terms of drainage, providing the open drains, then providing chutes, and then providing whip holes in all the concreting structures we had done for the protection purpose. And now this is the finished scheme, where we have like RE panels have been jacketed, then the existing RSW wall has been jacketed, and the fresh construction has been done from bottom. And design support and construction has been, I will acknowledge Terry Army, and the designers are here also. If we have any questions, we can ask. And the construction was done in a record time of 4 months. And that's from my side, and I hope that I have done justice to time, ma'am.
Well within the time, and your illustrations and the details you have shared with regard to right from starting of the borehole studies, and then your concerns with regard to the time limitations of the economics of the project. These things were covered well, and with different methods we have tried to take the options, and then the parallel activities we are doing to do within the time frames given. Thank you for your presentation.
Questions from the audience?
Hello, this is Salman from GQ. Just I have a few questions. What are the toe protection measures considered for SMAC wall? And the second, I'd like to know about the connection between uh, nail and the strap.
The connection systems there was a welded system because the thing is that we have been facing a lot of theft in the area. So previously a different connection system was provided, a patented item for Terra. So I would ask them to debrief on that. But later on it was a welded system because in these construction sites thefts are rampant. To protect those we didn't use any loose connection system but welded the system.
And toe protection measures considered?
Toe protection measures were required and we provided stone pitching.
Stone pitching, okay. And any specific reason for providing 400 thick drainage bay?
Sorry?
400 drainage bay, because in drawing it's shown the drainage bay thickness is 400
Yeah, those were also the patented items for the drainage bay. Those were drainage items, were patented items from Terra. So it was not the 600 of filter media that we usually put. It was not required because it's a material item.
Okay, ma'am.
Any other question? Over to the organizers.
Thank you,
Thank you,
all.
ma'am. Thank you for your presentation.
Madam, please wait, please wait. Thank you, ma'am, for the valuable insights on the failure and retrofit recertification reinforced soil wall on Hill Road. Ms. Atasi Das, ma'am. Thank you, ma'am. Thank you, sir. Next keynote lecture is on challenges in execution of pile and weight foundation for infrastructural projects. Please join me in welcoming Dr. Sunil Basarkar, sir. I would like to give brief introduction. Dr. Basarkar, sir, currently serves as Geotechnical Engineering Design Head at SNR Technology. He has industry experience of more than 19 years and 16 years in association with academia in the area of geotechnical engineering. As a field professional, he is actively involved in geotechnical deliveries and foundation solutions for marine metro, highways, tunnels and infrastructural projects across India, Afro-Asian and parts of Europe. Basarkar sir is graduate in civil engineering from National Institute of Technology, Rourkela, postgraduate in geotechnical engineering from Pune University and doctoral research in pile foundation from IIT Bombay. Currently serving as Vice Chairman, Deep Foundation Institute of India and has supervised introduction of CFA piling technology in India. He is co-convener of BIS Draft Codal Guidelines of CFA piles. He is also fellow of Institution of Engineers India, Indian Geotechnical Society and Indian Institute of Bridge Engineering and also served as editor of DFI Journal USA. Dr. Baraskar has about 60 technical paper to his credit published in journal and conference proceedings. Now I request Dr. Basarkar sir to please start the lecture.
So request you to please take 20 minutes time for your lecture.
The slides, please. Thank you to the organizers. Thank you to the chairs. I try to honor the timeline. The presentation is quite intensive. Heavy geotechnology related to the foundations. It will be a rapid fire presentation in a pursuit to wind up my presentation by 20 minutes. Thanks to the audience in advance for the patience hearing. And I'll be taking up the challenges in piling and the well foundation. This is the presentation background. It covers 2 case studies along with the background of the sites involved. See, plenty of times I find that the cases related to the challenges, failures of piles and the well foundation, they are not actually narrated. They are not on records. So I thought, let me have 2 case studies that will project what are the challenges. One is related to the success of the deep foundation. The other is related to the failure of the deep foundation and how those failures were remediated. Well, come to the development of the pile and the well foundation. We find pile technology and the R&D inputs are increasingly, pumped, and more outlay, financial outlay are provided for the R&D and technology development in piling. But not so in case of the well foundation. Well foundation, you'll find it still relies on the traditional methods of execution. We don't find any technology related to the well foundation. Whatever the technology is used, they are used for the enabling purposes to facilitate efficient construction of the well foundation. Well foundation is highly dependent on the weather condition, on the hydro condition, and the river performance. And particularly during the rainy season or in a deep water section, it's very difficult to execute the wells. And that is the reason wells are prone to the tilts, the overturning, and the shifts. And once that happens, your project is completely in disarray. Not so in case of piling. Pile have a better control in execution. There's a better understanding. We have even negotiated the stub-borne substrata material, hardest of all the rock, through a technology of piling. Take this for example. On the left we have a heavy-duty piling equipments. One we call a RCT, the other is the down-the-hole drilling. It can give you a pile diameter even up to 8 meters. If you have a RCD, 8-meter pile diameter, and it can go up to even 400 meters below the earth. This is astounding. That means the technology is ready, but the designer has to accept that the piling can be done up to 400 meters. On the right side, you find the traditional photo containing the construction of the well foundations. Still, we are using the same old barge, same old grabbing technique, same old cranes are used. Only the experience of the contractor is a matter of expertise that is used. That is what matters in the execution of the wells. So, keeping this in mind, availability of technology for the pile, outdated technology for the well, it is quite clear that piles are here to replace the well foundations in the future. Well foundation execution, how they are executed, there are many ways of executing. One is a traditional way, which is performed in the land, which is by gravity method. You actually pitch and align the well on the ground, and then you start dredging. The well will sink, add more modules on the top, the well will sink. This is the traditional method number 1. If you find that there is some resistance, you can do the jetting of water at the bottom where the pipes are provided in the steining wall, or you can free some of the friction at the lateral side by air jetting. The third one is additionally, first 2 method fails, we'll be using the jacking at the top of the steining wall, and we'll be pushing the well downward so that it attains the tip. Pneumatic sinking is outdated and highly dangerous nowadays, and I don't see any future for pneumatic caissons. Although there had been reported cases where pneumatic caissons had been used, it serves as an observation of the base of the well, but there are a lot of fatalities involved in the use of the pneumatic caissons. Highly outdated and not at all recommended today in matter of safety. How they are actually executed? See, if it is in land, then we have the first type of construction in which you are going to pitch the well, and then you are going to grab it, remove the soil inside, and then you are going to sink the well further, followed by the concreting. If the water is at between 3 to 5 meter, you are in position to provide a filling and what we call a sand island method. Now, if you find that the water head is still higher, 5 to 8 meters, we are going to create an enclosure, typically of a sheet pile or even a burley piles can be used to form an enclosure, backfill it, and then you are continuing the construction by a land mode method. Now, suppose if the water depth is more than 8 meter, even up to 14 meter, 30 meters, then you actually prepare a caisson in the ground up to a certain height, provide a plate at the bottom, and then you slide it in the slipway and you take it in a floating manner through the towing method, which you can see on the right side figure. You can tow the caisson and bring it to the actual point of execution. You are ensuring that the alignment and the center line of the well is as per the location, and then you're trying to tie the well together through a series of ties, and this is a highly proficient work that is involved, and it involves lot of involvement of the capacity of the ties, capacity of the anchors, capacity of the strings and cables. So having said, what are the methods of execution of the wells? Wells are highly prone to tilts and the shift. It is important, the name itself is self-explanatory. Shifting is deviation from a position. Permitted value is about 150 by IRC, or it can be a contractual value that is a permitted value. The second is tilt. If it deviates from the vertical alignment, then still it is a matter of concern because it can cause overturning. A permitted tilt is 1 in 80 as per the IRC. There are several items, there are several causes of tilt and shift. Variations in the strata along the cross section, or if there is a difference in earth pressure, or if there is a presence of any obstruction that can result in tilt and shift. In fact, the variation in the river cannot be captured, the substrata cannot be captured by traditional investigation method. So whatever is the observation you're actually finding during the execution, you have to negotiate then and there itself. Take the first case study that pertains to the overturning of the well at the Kosi River project, which is at Bihar on the eastern side of India. So this is a typical layout. We have the Uday Kishanganj end on one end, that is abutment, and Bhipur end on the other side. The bridge was necessity because otherwise it is to take to connect these two towns by a 72-kilometer stretch. On the construction of the bridge, this 72-kilometer stretch was going to be reduced to 12-kilometer length. So highly important in matter of connectivity and connections. So you'll find that the bridge, it consists of the main three marine stretches. There are three rivers of the Kosi, this tributary of Kosi, which is Ghagri, Budna, and Trimohan. So you can see the rivers across this bridge. That means the bridge were to be rested on the well foundation constructed on the land. Few of the well foundation were constructed on the three rivers, that is Ghagri, Budna, and Trimohan river. All the wells were 8.5 meter diameter and they were with a 1.25 meter steining. So we went ahead confidently with the execution of the wells. You have to remember that any time when well foundation is to be executed, it has to be done in a dry season. It cannot be done in the wet season, particularly the monsoon area around. That means we have a window for working only from November to May. May to October stands as a monsoon area where the flooding water and the river water is always high and it doesn't permit a safe execution of the wells. So we were in position to complete within that window availability about 39 wells in our scope. One problematic well was P124, which turned out to be it did not follow the execution norms which we had anticipated. So P124 was located in Trimohan river and it had a 14-meter waterhead. It was supposed to actually meet and grounded at about 13 meters, and the total plant depth of this P124 well was 27.26 meter. So you can see the key levels related to this well foundation. Now the chronology of the event, the well was started well, it went on confidently, but then some incident took place and a gradual overturning of this well occurred. 22nd April was the day where we floated the caisson and we took it to the position and aligned it. Gradually on 19th May, the caisson was grounded. That means the entire unit was reaching the bed of the river. 26th May, after grounding, 2 more modules were added and the concreting was done. That time, the height was about 24.76 and sinking was 7.1 meter below the bed. 1st of June, the observed tilt was in the downstream side. Porcupine, that is a measure that is used for the flood control measure, were obstructing the sinking of the well on one side. And this was the major reason why the tilting of the well started. The 10th of June, we still started grabbing and we removed few porcupines and even additional porcupines were discovered. This was a great obstruction which was not captured in the investigations. Then on 17 June, there was continuous rise of the water level. Mind you, this was the monsoon has already onset. Water was rising like it was posing a threat. So to negotiate that, we added 2 more modules so that we are above the water level. But then, sadly, on 18 June, further 2 meters of water rose because there was a water that was released from the Kosi barrage. Due to the heavy influx and increased velocity, the tilt got aggravated and the entire 27-meter well, it overturned, it sank, it went below the river. So this is the position. At the center, you can see P124, completely overturned well. On other side, you have an abutment P125, Pier 125 on this 123. At the bottom left, you can see the grounded operation of the well. On the right, you can see clearly that the well has tilted and all the operations are in place to restore the tilt of the well. So working overnight under a very treacherous condition, that's what the working with the well is like. The remediation was required, P124. What was the option? Either you change the span. If you change the span, the waterway width is obstructed. It is not as per the norms, so that was ruled out. Option 2 is change the alignment. Central line, you change it. But already P124 and P126, P125 were already constructed. So this was also ruled. Option 3 was you salvage the well or you break the well that is already sunk, clean it and again install a new well on the same location. This was considered as alternative 1. The option 4 was a out-of-box thinking gathered together through a set of consultants, our own parties involved, and we thought that instead of having one well at the center, why not have 2 wells adjoining and try to bridge it with a portal. A longer method, but yes, things were under control. So we decided to take up alternative 1 and alternative 2. Alternative 1, that is salvaging the well, creating a new well, it was requiring 10 months, additional 42 crores were involved as a fixed cost overrun. Matter was considered with reservation. Alternative 2, it involved higher investment from our own company. But yes, it was definitely an achievable target. So we went on with the 2 well. Remember, with the 2 well, the load of the pier was distributed and it was 50% on each well. So that was the advantage we were having. So with this, we went ahead and we constructed the 2 well systems and we tried to raise, since the SBC was required was less, we tried to raise the riverbed level by 10 meters. Raising the riverbed by 10 meters, it turned out to be advantage for us because the length of the well was also reduced. So with this system was followed. On the bottom right, you can see that the raising of the bed by dredging sand is taking place. This is the towing of the floating caisson to the alignment. The first lift of the well is called a K-lift system. That is the first in which the hollow steining is actually taken in a floating condition to the site of performance. So this, once the grounding of this well, 2 wells were done, subsequent modules were added and we could reach the top, designated top of the well. So this is a schematic of each module for the well 124A and 124B, which is on left and right side. So this is the construction. You can see the additional module being added to the twin wells. The well is ready on the left photo, and there is a portal beam support system in picture. And on the right, the concreting of the portal portion is taking place. So this is a very symbolic picture where the wells at 124 are almost ready, but then on the left, all the construction, including the deck, is ready. That means definitely there is a delay of the project due to this well, but thankfully we could actually recover about 4 months by this thoughtful process. So there was a lot of benefits. 10 months had been saved, and there was some saving in the cost also compared with the other options. The saving in the material and execution was 1.05 considering the options we had in crores. Take the second case history. How much time I have?
So you have 4 minutes time, sir.
I'll try to wind up an interesting case study. I'll forgive the question answer session because I'll try to entertain the questions out of this forum. Thank you very much. The Raker pile in Volta Bridge, this pile is important because anytime the raking of RCC pile is one of the biggest challenge. And here we have an example of a 1600 mm diameter raking pile at 1:5 going into extreme length of 76.5 meter. Gentlemen, for all of you, this is a world record and we are trying to negotiate with the Guinness Books of World Record to see that this pile achieves a presence in the record book. So now if you see the project, it is a Ghana Rail Development Project, which is a 100-kilometer railway project, and part of this railway project was the Volta River Bridge project. So this was a 300-meter long bridge having 5 spans, each span of about 60 meters, and this was some of the salient information. The diameter of the pile was 1600 mm, and the length of the casing extra at the highest point were about 70 meters. These were some of the elements which were used. Abutments and all other locations were resting on 6 piles, abutment A1 and A2, and P2 were resting on 6 piles. All other piles, all other piers were located on 4 piles. That was the scheme for this bridge. There was interesting change that took place. Earlier, when we commenced with the design and all the mobilization got started, the PGA coefficient for the earthquake was 0.16. Gradually, all the equipments, machineries, manpower was deployed at the site. And that instant, only the Ghana code was revised, and this PGA coefficient was increased to 0.35. So that was a shock for us, that all the mobilization, every investment has been done to mobilize our equipments for the bridge. And suddenly we find that the design has to be completely revised. We're trying to negotiate with our Italian consultant, but he was not at all willing to agree. So we had to design everything for a very high seismic force, which invited lateral forces, very high lateral forces. So to negotiate high lateral forces, we had 2 options. Either you go for an increased pile diameter and more number of piles. That means 2-meter diameter of pile, 48 in numbers were required for the vertical piles. Then we also thought of a raker pile. The raker pile diameter was reduced about 1600 mm, and the numbers were also reduced from 48 to 30. The pile cap requirement for the raker pile was also reduced from 6.2 into 4.2 meter into from 26.5 into 8.5 meter. Raker pile by all means were a great saver for us, but only thing was that it required a challenge of execution. So this was a U-shaped Volta river. You can see the high depth of the sand, which was a challenge by itself. The piling were supposed to be socketed 10 meters into the gneissitic type of rock. You can see at the bottom the UCS is hard, 20 to 70 MPa value. It was a hard rock. That means it required a very heavy duty machine. So we deployed RCD rig to negotiate the hardest of this socketing material. So this was the actual layout of the piles from abutment 1 to abutment 2 passing through piers 1 to 4. So this is the process that was involved. You have to drive the liner for the temporary platforms. On the right, the temporary platform is created. Then you drive the liner in inclined manner and house the RCD rig on the liner, because that's how RCD operates. So once the RCD rig is put up and the setup is there, boring is done. After the boring, you have to insert the rebar cage in inclined manner. Inclined lowering of the cage itself is a challenge because it requires a lot of in-situ arrangement so that the cage moves without any obstruction, followed by the concreting. Concreting also requires a tremie which has to go along the alignment which is inclined in direction. So these are the challenges, but yes, it was overcome. Now the waterway
Sir,
was
request
not
you to
available.
conclude in a minute, sir.
Yeah, give me 2 minutes. Waterways was not available, so that any activity for the superstructure and even the piling was not possible. That means we have to fabricate the barge within the confines of the Volta River. So this 44 meter, 16 meter and 2.2 meter barge was fabricated into the site, and this barge was used to house a 260 metric ton crane. So this is a quick look at, this is the pile liner driving through the vibro hammers, construction of the platforms, the construction and towing of the hollow liner for the raker piling. Then this is lowering the RCD rig, and that is housed on the liner, doing all the RCD operations. Remember, RCD requires about 1200 meter cube per hour of water, which means if you are going to suck this amount of water, the whole pile, hollow pile will be empty. So we had to arrange for 2 pumps that could pump about 700 cubic meter of water per hour, so that a standing water within the pile hole was maintained. So all the crushing bed, they were actually examined through the wire mesh, and once it was confirmed that the rock length is achieved, we were terminating the pile. This is a reinforcement cage lowering in an inclined manner. The tremie operations, special arrangement required for tremie. We had to provide a chair and a cylindrical curvature plate so that the tremie can glide along the plate to the bottom of the pile. So this is a concreting arrangement, a hopper and the tremie provided. So that was a 76.5 meter pile. Concrete volume was 160 cubic meter. The concrete was actually planned, and the design was done in such a way that it had a setting time of 10 hours. For those who are actually familiar with board pile concreting, will be appreciating the 10 hours of setting time is important for a long pile. This is the completed piles for us. If the challenges involved, rock touch level, any variation that was affecting the design. Our designers were in Belgaum, they were in Delhi, in Mumbai. Our PMC were at Italy, so it required around-the-clock monitoring of the rock touch level. Once the designer confirmed that, okay, rock touch level is not going to invite additional lateral force, then we can resume our construction. Until and unless the designer actually cleared the RTL, rock touch level, we were not in position to commence the further operation. That was a big challenge. Liner driving was never an easy task. There are a few cases where a sand blowing was occurring below the liner, but yes, it had to be negotiated. So this was the hopper arrangements, then there was a modification in the tremie, and this is what the beautiful bridge looks like. You will see on the left side is a innocuous bridge, very serene, very calm, but yes, the struggle, the challenges that had been encountered in laying the foundation were unsurmountable, and we have a railway line on the right. To conclude, yes, we have a technology that can give any solution to the piling problems. Hardest of the rock, biggest of the diameter, deepest of the pile can be negotiated with the application equipment technology. Whereas you find that the well foundation technology is a traditional method. Lot of accidents are taking place, lot of deviations are taking place, and there is a lot of delay in execution of the bridges. The delay can take about 1 year, 2 months, to even 4 years, because solution is always eluding us. If this is so, then the point is, it is always better to replace the well foundations with the piles. That is the bottom line of my presentation. I thank the organizers, I thank the AFCONs from whom the contents have been derived, my present organization, HR Geotechnic. This is something of a record. We do a lot of projects. If you see the right side, we discovered during a tunneling operation a cave full of jewels. Normally, this kind of stone is used as an amethyst. It is a jewelry that is a coveted jewelry, but here we discovered a complete stretch of the amethyst tunnel lining. Thank you very much. Thank you for patient hearing.
Thank you very much, sir, for your elusive presentation. We all know very much that soil itself is complex in a site, in a place, but again, after all the investigations or the detailed designing, everything, whatever we do, there are occasions we surely face challenges, as you have been explained today. And the techniques to overcome these challenges, the construction methods, the latest developments and the equipment being used, we have got a good insight into the details, sir. Thank you very much for your presentation. We also wish that you, AFCONs, and yourself will get recognized by Guinness Book for the World Record. We expect that, and it will be a pride for us also. Over to the organizers. As sir was mentioning, the questions can be taken up during the leisure hour.
Thank you, sir, for the valuable insights on challenges in execution of pile and well foundation for infrastructure project. Now I request Chhatrapati sir and Cyrus ma'am to please felicitate Basarkar sir. Thank you, sir. Thank you, ma'am. Now we will have corporate presentation by TechFab and Strata. I request TechFab representative to please start the presentation.
So we'd like to have for 5 minutes, please.
I would like to thank the organizers to allow us to give a corporate presentation. So I am Divesh Rohit from TechFab India. So I will start my presentation with our journey, which started in 2003. Since 2003, we have been adding one product every year, and by the end of 2024, we are having more than 25 products in our product portfolio. We try to provide our customers with innovative and world-class products which can help them create sustainable solutions in their projects and reduce cost. We are the largest manufacturers of geosynthetics in India with a portfolio of more than 25 unique products. All our in-house labs are NABL certified, and 2 of our labs are GuiLab certified. GuiLab is a certification from USA. And TechFab India is the only company in India to hold the BIS license of all the 14 geosynthetic products which are under the BIS license regime. And we have 40 in-house designers for diverse projects, uh, including the all supplying to all over India. We also export our products to more than 40 countries. And recently, last year, we opened a subsidiary in USA, which provides sales and technical support. So our manufacturing facilities are located in Dadra and Nagar Haveli and Daman and Diu, Haridwar, and one upcoming in Bhopal, near Mandideep. These are some of our manufacturing facilities, and all our products and manufacturing facilities are accredited with various national and international certifications for lab quality and other environmental related certifications. 5 of our products are certified, EPD verified, which shows how they can support towards sustainable we provide a wide solutions to the wide sectors, which includes port and marine infra, logistics, power and mines, waste management, real estate, aviation, transportation, and drainage and hydraulic structures. So we have a dedicated design team for RS structures, geohazard mitigation systems, ground improvement, pavement designs, and hydraulic structures. For RSS structures, we have panel fascia, walls, RS slope, well mesh walls, Gabin fascia structures which are for near via hydraulic facing, and a block fascia. We also do Gabin retaining walls for various structures and for hydraulic river protection systems. We are the only company which manufactures PVD in India, and we provide complete design solutions along with the product. We do ground improvement with geocells, with geogrid, and also provide railway ballast and subballast stabilization with geocell and geogrid. Our pavement design team helps in reinforcement of granular bases and sub-bases with biaxial geogrids, polyester and PP both. We provide solutions for slope erosion protection with geocell. And with Gabions, we provide hydraulic riverbed protection and allied hydraulic structures. We have geomatrix and geobags, which are widely used for riverbed protection, and also provide support for coastal and shoreline protection. Along with that, we also have a rockfall protection systems and a team which gives complete solution for the design and the products. This is also for rockfall protection system and debris flow barriers. And I would like to introduce a new product which we are working with Concrete Canvas. It's a UK-based company. It's called Concrete on a Roll. So there are 2 types of products. One is CCXU, which is for utilities or slope erosion protection, and other one is CCXM. It's written X, but it's M. It's for hydraulic structures, for lining of hydraulic structures. And this is the only product in the world which satisfies the ASTM code for the geosynthetic cementitious composite mat. It helps in rapid installation. It's easy to use. It has a low overall project cost and low carbon footprint. As you can see in the pictures, it can be used for slope protection, canal lining. The mix which is there in this mat has more than M70 strength. It has a high flexible strength and high flexible resistance, and also durable in various environmental conditions. I'll just show you the picture which shows the difference between concrete canvas and poured concrete. You can see here the poured concrete, which is generally used for canal lining, is very brittle and in a band test. And whereas concrete canvas still sustains a lot of cracks, but it doesn't cracks.
Can you please run through?
So these are the various installation procedures. First, if initial slope, then you, just 5 minutes. Then you finish the slope, create a trench for installation, lay the product, anchor it, cure it with water, and then you're done. These are the various applications for slope stabilization, culvert lining, ditch lining, bund lining, and concrete remediation. Thank you.
Thank you very much for your presentation. Over to the organizers.
Thank you, sir, for the excellent presentation. I request session chair to please felicitate sir.
अरे पापा मेरे दांतों का
Next will be corporate presentation by Strata.
Miss, you have 5 minutes for your presentation.
Yes, sir, sure. Good morning to everyone. This will work. It's not working. Sorry, it has already taken 2-3 minutes. In the meantime, I'll just introduce myself. I'm Shabana Khan. I'm working as an assistant vice president in a technical division for Strata Geosystem. In the 5 minutes presentation, I'll just brief you about what all products we deal, what all applications we deal, and how Strata is like evolved from just an supplier to a largest manufacturer in the world. मुझे लैपटॉप ही दे देते ना लैपटॉप ही दे देते ना पॉसिबल है हाँ राइट इट्स ओके इट्स ओके इट्स ओके It's okay, you can do that. I'll just speak. That's not a thing. 5 minutes hai, we'll just cover it faster. Everybody knows about Strata, so I'll just cover the products. Thank you. Thank you so much, guys. As I said, in 5 minutes, sir, I'll just quickly cover what we do, what Strata is all about. Strata is a global leader in geosynthetic product manufacturing and providing the geotechnical solutions. We started as a very humble beginning in 2004 by associating with US team. In 2009, we put up a plant in Gujarat, in Daheli, for making the geogrids. Now we are making almost 6.5 crore square meter of geogrids annually, including biaxial and uniaxial. We launched GeoCell production unit in 2012. We were the first initiator of GeoCells in India. And now we have almost 4 products which we are making in India in the Daheli factory. We have a patent for RS wall, also an RS block. Our factory is in Daheli, which is spanning and spreading over 320,000 square feet. We are also planning to enhance the entire manufacturing unit, go almost 1 million square feet by adding few more product portfolio in our basket. We have our laboratory, which is NABL accredited, as well as we are GILAP accredited. So all our products are tested in the factory with the team which has the experience and expertise in testing the products. We are in association with a Glenraven, which is 140 years old company, which are expert in technical textile and a performance textile. As I said, we are dealing entirely in geosynthetic based soil solutions and provides the highest quality of product as well as the solutions for civil engineering problems. Our office headquarters is in India, located in Mumbai, factories in Delhi, offices in US and Spain as well. Three vertical of strata deals with manufacturing of the product. Entire set of 200 plus design engineer, we have it in Bombay. We have almost 400 plus engineers in our construction division. From manufacturing, from design as well as executions. So the entire set of solutions are being given by strata. Geosynthetic has taken a place of almost a construction material like steel and concrete. Why? Because it is a polymeric based material which enable a sustainability as well as it enhances the construction time, like it's a very rapid construction material, which allows us to save our natural resources and allow us to execute the projects very fast, which reduces the carbon footprint as well. In our product portfolio, we have Strata Grid. As I mentioned, we produce 6.4 crore square meter of geogrids annually. Strength varies for uniaxial around 1000 kilonewton per meter. In biaxial goes up to 200 kilonewton. Strata Web, highest production capacity we have. Strata Tex, which is knitted woven geotextile. The strength for the woven geotextiles goes up to 1200 kilonewton per meter. We have added one more product, which is a drainage composite. We have three ranges of it. In India, I think we don't have many producer which can vary the different types of products. So in Strata Drain, I'll just cover briefly what all we have. In the grid, I don't have to speak much about it because everyone knows about GeoGrid and its applications mostly goes for a reinforced soil wall as well as for the soft foundation when we are executing the embankment, for the pavement stabilization as well as for veneer reinforcement in landfill. Maximum consumptions goes for RS wall. We make strata block. Actually, we are the initiator of quite a big movement in India to use the block in a larger way. So modular concrete block fascia with strata grid, strata wall and strata slope. Sir, I'll make it faster. This is some of the projects what we have done it in India as well as abroad. We have done the sea walls as well and also being used for the complexes like residential complexes retaining wall done in NASA Causeway and stabilization in Myanmar for the pavement where we enhances the stability as well as reduces the thickness. We need reinforcement for landfill, capacity enhancement of the landfill. Strata Web is an HDP material which has a texturing and perforation for friction and drainage. We have a variety of product available in a width and length and height, and the color is being varied for the slope. Strata Lock, Strata Fast, Strata Cord is an accessories of web which enhances its alignment and the adaptability to the sloping surfaces, used for the load support, for the retaining wall as a liner and erosion control. Some of the project for the load slope for landfill, reservoir lining, as in gravity retaining wall, as in reinforced soil wall with the green color as in reinforced fascia. High knitted woven geotextile, just wanted to tell you about the strength which it goes up to 1200 kilonewton. It performs very well if we compare it with the just an uniaxial geogrid or a biaxial geogrid for the soft foundations. So its application go for the ground improvement, load transfer, paved road and unpaved road. Some of the projects. The strata drains come with the three types. One is the strata drain, which is adaptable for all the applications. TD goes for the high performance in high pressure, when we can use it replacement of gravel for the landfill as a leachate collections, and starter drain which goes as in high flow. Very best option for where we have a highest rainfall goes for a landfill capping system. Used for civil work, landfills and mining. One of the projects in Spain where we
Madam,
have
you may
used
have
for
to
the
conclude
capping. Sir,
fast.
I'm done almost. It's being used behind the retaining wall. Sleeve it for the anchoring system. Why Strata? Because we are the largest maker of geogrids and other products. We have built almost 2,000 plus structures in India, including block wall as well as panel wall. Almost 1.25 crore square meter of fascia of RS wall, including all the types we have executed in India. We are the first maker of geocell and the leader in geosynthetic space. We are there, and most of the people who are present here are there in the committee of BIS, where we are IRC, Ministry of Textile, where we are helping to develop the guideline for geosynthetic in a larger perspective. As I said, we have 200 plus engineer, 35 design engineer, multidisciplinary design engineer with us, and focused mostly on enhancing the product technology, having the global technology, bringing it to India, making it more localized, and the team is entirely focused on this. Multiple certifications we have. We have a GuiLab certifications of our international government bodies who have used startup product is being listed here. Indian NHAI, Railway, RDSO, BRO, most of them have
Request you
used.
to conclude.
We are done, sir. Thank you so much.
Thank you, ma'am, for the excellent presentation. Now I request session chair to please felicitate ma'am. Thank you, ma'am. Thank you, sir. Now the next keynote lecture is on assessment of safe vertical cut height for rock slope in Garhwal, Himalayas. I welcome Mahendra Singh sir to please come on stage. Before starting the lecture, I would like to give a brief introduction. He is BE Civil Engineering in 1983 from MNR Engineering College, Allahabad. MTech 1985 Hydraulics and Water Resources from IIT Kanpur. PhD 1997 Rock Mechanics from IIT Delhi. He is currently President of Indian National Group of Society of Rock Mechanics. Organized IGS for 2002, 2003, 2013 and 2023. Guided 15 PhD, more than 60 MTech theses, published more than 150 papers in conferences as well as journals, actively engaged in several BIS committees related to rocks, received several best paper awards. Now I request sir to please start the lecture.
Thank you very much, Honorable Chair, Co-Chair, and dear friends. The topic on which I am going to speak is assessment of safe vertical cut height for rock slopes in Garhwal, Himalayas. And here with me, the main work has been done by my student, Lal Shuai Kima. He is from the Civil Engineering Department, and my another colleague, Dr. S.P. Pradhan, from Department of Earth Sciences. So this is the outline of my talk, introduction. Then I'll talk about the motivation, objectives, then what was the methodology we have used, and then I'm going to talk about an index which we have proposed, JF slope for rock slopes, and then a multigraph technique. And our target, the stakeholders are the field engineers,
especially for field engineers, we have developed this particular system. And then some, if time permits, how much time is available, sir, with me? 20 minutes? You can
20
just
minutes,
tell
sir.
me.
You are requested to take 20
Pardon?
minutes. 20 minutes.
20 minutes. So you can just tell me 2 minutes in advance, I'll close it. So if time permits, some case studies and then conclusions. Here I'm showing you the map from my own state. And you can see here it is one of the most important projects. You know, Government of India is very keen on developing the infrastructure in remote hill areas. And here is the Char Dham National Highway project. You can see Yamunotri, Gangotri, Kedarnath, Badrinath, and Haridwar, and they are connected with roads. And around almost 900 kilometer long national highway is there, and the aim is to make it all-weather road with at least 10-meter width. So when you are going to do the road widening, this is going to happen. So what normally is being done is you cut the slope. It's a very steep cut. Majority of the rock slopes will be looking like this, and the stability of these slopes is very, very important. If I want to go into the stability analysis of these slopes, the very important thing which I have to look into is these structural features, which we call as discontinuities or joints or fractures. And you can see here that on the right-hand side of this hill, there is a steep cut, vertical cut. It's almost stable, whereas on the left-hand side, if I make this cut, it will not be stable. So the orientations, their dip directions with respect to slope face is very, very important. So these structural features are extremely important in governing the, creating the instabilities. So the motivation is that there are steep cut rock slopes are being constructed in the highways, along the highways in Himalayas. And these sites are affected by landslides, mainly due to failure of steep cut rock slopes. And what is being made responsible for this is that the geology or the severe climatic conditions and the activities like road windings are reported to be the main cause of these instabilities. So, if we have to make it safe, generally what we have to do is, we have to do the analysis, we have to do the field testing, laboratory testing. All of you are familiar with this. And the problem is that there are hundreds of sections along the road, and you cannot do analysis for all of them. And what a field engineers need is a simple tool to assess the safe height of the cut slope. So here the aim was that we should try to find out some system where, using which the field engineers, without going in much detail, with simple input from the field, can assess a rough assessment. They can have a rough assessment of the safe height of the rock slope, cut slope. So another thing is that, especially in my state and other states, in the hill states, we are seeing that the occurrences of extreme events is now large. There are many cloud bursts I hear these days as compared to what I used to hear in my childhood. And in many times we have to look for the alternative routes in emergency situations. So where you don't have much time, you don't have much resources, so their rough assessments is required. So for those situations, this particular objective was made. So the objective was development of quick decision-making tool to estimate the safe height as well as the hazard due to steep cut rock slope. And I'm going to talk about this particular development, multigraph technique, which we have suggested, and the GF slope, which is an index which we have suggested. And as I told you, the stakeholders are mainly the field engineers.
So before embarking into that, so let us see what are those features, what are those factors which affect the instability. And here I bank upon my background at IIT Delhi. A lot of work has been done on these aspects, how these structural features affect the stability or instability or strength behavior or deformation behaviors of the rock masses. So same thing is going to happen with the slopes also. So as far as slopes are concerned, and if I talk about the joints, there are three major things which we have considered here. First one is the orientation of the joint plane. Second one is how intense the jointing is there. It is a low frequency or higher frequency jointing. And third thing is how much rough these joints are. So these three parameters we have taken as the basic parameters, and these photographs show you some classic work which was done at IIT Delhi long time back. I'm not going in detail, but this gives us a very good idea, background, how the orientations, etc., or the properties of the joint are going to affect the structure. So the first most important parameter, as I said, is the joint inclination. And when I say joint inclination, it is the dip and dip direction of the joint plane, and also the dip and dip direction of the slope face. Both are important, and the difference between their dip direction is going to govern the slope. So in these figures, plots, I have shown what is dip and dip direction and all that. And based on these values in the field, we know you may have different kinds of failure, for example, planar, wedge, toppling, and so on. And these, again, from my PhD work, in fact, these photographs I have taken. At that time, we did it for strength behavior, but they resemble very much with the slopes also, where the slopes especially failing under sliding condition or under toppling condition. So that gave us a good background. And here is a joint inclination parameter which quantifies the effect of joint orientation on the strength. So we have used this inclination parameter in development of the index which I'm talking about. The second important parameter, as I told you, is the frequency of the joints. If the rock mass is intensely fractured, or if it is moderately fractured, or it is massive, it is going to make a lot of difference. If there is low frequency of the joint, you are going to have relatively safer slope. If the frequency is very high, you are going to have likely to be more instabilities. And one can do the scan line survey, and from there, using the tape and simple techniques in the field, one can come out with the frequency of the joints. One data sheet from scan line survey I have shown here. Some mathematics is required, which I am not discussing here, which you can use, and you can find out what is the frequency of the joints and so on. The third parameter, which we have considered very important, is the roughness of the joints, and there are procedures available. For example, Barton's charts are available, which can provide you the JRC, joint roughness coefficient. We have used this particular system in our index. And here I have shown the Barton's comp profilometer. You can use it in the field, and then matching the field profile with these standard profiles, one can assign what is called as joint roughness coefficient. Besides the joint properties, one more important thing is how strong the intact rock is. As far as the slopes are concerned, I think if you use Schmidt-Hammer test to find out the joint wall compressive strength or the strength of the rock, that is sufficient. So these are the things, these are the parameters which we have used. Now I come to the methodology which we used for this development of this system. So we conducted field studies, a lot of field work was done, and this is the site which is on National Highway 58, Rishikesh to Kudiala in our state. And we selected 50 slopes which had shown instabilities, and these are the data which we had collected. So observed data was slope angle, dip direction of the slope face, dip and dip direction of the joint planes, then joint properties. We did scan line survey, the height of the slope. In the height of the slope, we have divided into two types. One is which is stable height and safe height, and second one is unsafe height. Safe height is the height which is showing no failure, no signs of failure, and unsafe height is there are presence of loose blocks, wedge formation, etc. This is one typical data sheet from the field which the student used to collect, and then he used to do the desk study, analysis, joint frequency, etc. And then finally, this is the system, this is the index which we have proposed. It is similar to joint factor concept which was developed at IIT Delhi. So JF slope is defined as Jn upon n corrected into R. In the numerator, you can see there is a term Jn which is representative of frequency. So it is the number of joints per meter in the direction of loading, that is vertical direction. And in the denominator, we have joint inclination parameter. This joint inclination parameters quantifies the effect of inclination. Here we had to correct it because not only the orientation of the joint, the inclination of the joint is important, but also it is important in which direction the joints are dipping. So we had to correct it. So we have taken apparent dip in place of the true dip. And third parameter is the strength. R is the strength parameter. It represents the shear strength of the joint. So these parameters are in the denominator. And to find out the friction angle for the joint plane, we have used Barton models. And Barton model gives phi j equal to phi r plus JRC log 10 JCS upon sigma n. And we have suggested this chart also to calculate the phi j value for the field engineers. So we did all these, we collected all this data. And finally, what we did was that we put this JF slope on the x-axis. And on y-axis, we have normalized the height of the slope. So gamma h upon sigma c, gamma is the unit weight, h is the height, and sigma c is the strength of the rock. And you can see there are two clusters of data. One is for the safe height, another one is for the unsafe height. And what we found was that there was a strong correlation between gamma h upon sigma c and JF slope. And as the JF slope is increasing, as the jointing is becoming more and more, the safe height or unsafe height, they are decreasing. So these two threshold limits we have obtained, and that gives us an answer. You can see here, we can divide this zone into three zones. The first one is high hazard zone, medium hazard zone, and low hazard zone. And their boundaries give you safe height and unsafe height. So once we have this parameter, once we have this chart, from this chart, I can calculate the safe height as well as an unsafe height, and I can compare it with the height of the slope in the field, and then we can find out whether it is safe or unsafe. Or for a given JF slope, I can also calculate what will be the safe height. So if you are going to cut a slope, you can in advance calculate roughly, it's a rough estimate, how much will be the safe height so that it is within limits. So finally, all those charts we have clubbed together, and for field engineers, we have proposed this multi-graph chart. Here you can see we start from the right bottom, and here on the bottom side, you can see the DD slope minus DD joint. That is the difference of the dip directions of the joint planes. Here, this chart is used to find out the apparent dip. On y-axis, you can see the apparent dip is there, and true dip of the joint degree is there. So point A, so from first we reach up to point A. From point A, then we go to the left-hand side, where there is a chart which gives you phi j degrees. It is the application of the Barton's model. So it is the graphical representation of Barton's model. And so phi j you get from the Barton's model, and up to phi j you reach, and then you get what is JF slope for 1 centimeter.
And from point B, then you go to point C. In this chart, you can see JF slope. There are given, the spacings are given 1 centimeter, 10 centimeter. So average spacing you take, and corresponding to that, you take point C. And from point C, you go to the right-hand side. There is a final chart which gives you high hazard, medium hazard, and low hazard. So if you have the H value, if you have already some slope, you can take that point from the top, and then you can find out the point D, and you can assess whether the slope is in high hazard zone or medium hazard zone or low hazard zone. Or if you are working out for calculating H, then from point C, you reach up to that low hazard line or the next line, and then you get gamma H upon sigma C, and from there you can calculate the H value. So this is the final chart which we have proposed. And finally, some case studies we have taken. So there are 5 slopes we took on a national highway, and we observed all the data, dip direction, joint planes, and their joint spacing, and then finally we calculated the phi j, JF slope, and gamma H upon sigma C, and from there we got the height. And what we found, these are the points. You can see on the right top, there are 5 points, 1, 2, 3, 4, 5. They show the positions of these slopes, and the observations which we made in the field were matching with this. So it's an approximate technique which can be used by the field engineers for quick assessment of the safe height or the hazard classification. So finally, these are the concluding remarks. So we have proposed an index which can be used to quantify the extent of instability in a steep cut rock slope. And the parameters which we need for the application of this technique are very simple. You need dip and dip directions, you need some Schmidt hammer test, you need some scan line survey, and then you can find out the safe and unsafe heights of the slopes have been found to be strongly correlated with this JF slope, and we have suggested those expressions that can be used to find out the safe and unsafe height. And finally, a multi-graph technique has been suggested as a graphical method which can be used for quick assessment. Finally, one point I have put here, that in this technique, it has been developed for a particular region. So the geology is particular, seismic history is already there, implicit in these charts. The meteorological, the rainfall intensity, maximum rainfall, all those things are already implicit. So if you want to apply it to some other site, maybe some initial few locations, you have to do the initial things, and then you have to calibrate these charts. So with these words, sir, I conclude my lecture. I hope I am within time.
Yes, sir, you're within time.
Thank you.
Thank you, sir, for this nice presentation, informative presentation. And also, as you have told, this will go a long way in providing a tool, an easy assessment tool for the engineers to get to know the safe height. Over to the audience for any questions.
Yeah. Somebody please give the mic over
Jai,
there.
Jai.
Two important factors for natural slopes is, one is a groundwater. So I don't know like how you have looked into the groundwater aspect, because the joint fluid flow through the joints will affect the stability in a big way. And the second important point is like the persistence of joints. I mean, you talked in terms of joint friction and spacing, but persistence, if it's completely fully persistent, then it's very unstable, but a little bit of like a rock bridges adds up a lot of cohesion. Thank you.
Thank you very much. The first point is about the water pressure, which you are talking about. As I told you, the our past history of the rainfall, etc., is already in the memory of the slope. So when we develop these charts from the field, when we say this is the safe height, this is the unsafe height, likely unsafe height, so that is already remembering those histories. So at that particular location. But yes, where you have a particular more flow of water, exactly, I think we will not be using it. We have to go for rigorous analysis. Your second point is regarding what? Persistent, yeah, that's a very important point, sir. What means, I think we can include it in our further studies when you talk about 5J. At the moment, the joint, this 5J value is based on considering them almost persistent. But you are right, if they are not persistent, it's going to make a lot of difference. There are many more other indices also. So we have considered at the moment 3, but yes, if you have more confidence that the joints are not persistent, then one can include them in the 5J value. But it's a very important, good suggestion. We can try to include it in our further studies. Pardon? Yeah, joint matching also very, very important. So there are so many factors. There are almost 10 factors, important factors related to joints. So those have to come into picture. Here, the point is the 5J which we have taken is not for the rock mass. It is for the joint. That is our thing. Yes.
One last question over there and then over to the organizers. I think. Organizers, please. You can take care. Thank you once again, sir, for your
That's all.
session
Thank
and
you.
the
Thank you.
clarifications
Thank
also.
you.
Thank you, sir, for the valuable insights on assessment of safe vertical cut height for rock slope. Now I request session chair to please felicitate Dr. Mahendra Singh, sir. Thank you, sir, ma'am. Now, next keynote lecture is on sustainability assessment of geopolymer stabilized highway subgrades using industrial by Dr. Prabir Kole, sir. I welcome Prabir Kole, sir, on stage. Before starting the lecture, I would like to give brief introduction about Prabir Kore is professor and director of the School of Civil, Environmental and Infrastructure Engineering at Southern Illinois University, Carbondale. Dr. Kole did his civil engineering from North Bengal University in 1993, ME in soil mechanics and foundation engineering from Indian Institute of Engineering, Science and Technology, Shibpur, 1996, and PhD from Indian Institute of Technology, Mumbai in 2001. He is PE from Michigan since 2013. After completing his PhD, Dr. Kole worked at Holland as chief laboratory. He became a faculty member at NIT Agartala University, Malaysia, Sarawak in Malaysia before joining SIUC in 2010. Dr. Kole has more than 21 years of experience in teaching and research. Dr. Kole is an expert in soft soil stabilization, mainly organic and peat soil. He did extensive work on peat soil and developed a soil sampler for peat soil sample collection. Dr. Kole has conducted research in areas of geotechnical and geo-environmental engineering. Dr. Kole has more than 100 peer-reviewed journal publication, book chapter and conference proceeding, and over US $1.2 million in research and training grants as PI and co-PI from OSPA, FSWA, EPA, IDOT, IIN, IBHE, Holcomb Foundation, etc. Dr. Kole advised 30 MS graduate students, 5 ME, 4 PhD, and served as external examiner for 32 PhD students. Now I request Dr. Kole sir to please start the lecture.
So you'll be having 20 minutes, please.
Good morning, everyone. Thank you for the kind introduction. And I also I would like to thank Aurangabad chapter of IGS for selecting me as a speaker. And so today I'm going to talk, again, today's speaker is from industry, so I'm going to talk about academia. I'm from academia, so obviously I'll talk very basic testing or soil stabilizations using geopolymer. So outline of my presentation, so background and problem, research methodology, experimental results, and statistical analysis, and sustainability assessment. Everybody is talking with the first speaker, the first day, so talking about sustainability, I'll talk about that, and then conclusions. So before my presentation, I'll talk about my university. I just take the privilege. Our university established in 1869. We are located at the Southern Illinois, is the heart of US. So we have more than 200 undergraduate program, HD master program, more than 30 PhD program, over $70 million research. So our university is R2, but it is going to be R1 soon. We have students from all 50 states in US and also 100 countries. We have very small faculty to student ratio, 14:1. We have a big competitor is Champaign and University of Maryland, Chicago, but we have everything. Even we have aviation department, we have a small airport, and then also medicine, and everything is there. Okay, so without further ado, so today I'm going to, as I mentioned, so basically I'm talking about soil stabilization. So everyone knows, first thing is why need to stabilize the soil? So obviously the soil is not good, correct? So these are the different, most of the cases, weak or highly compressible soil, expansive soil, collapsible soil, process-stable soil. And common method of this ground improvement technique is the mechanical modification. I mean, this is very common, like we need to add anything. Hydraulic modification, chemical modification, that's the one I'm going to talk, and then modification by inclusion and confinement. So mostly this, so these are some pictures you can see for the subsoil, how to construct on this type of soil. So there's a big challenge. So most of the time, I'll be talking about how to improve the subgrade and subgaze instead of using this conventional Portland cement or lime, okay, using geopolymer. Sorry, what is going on? So this is, again, I mean, this is the ground improvement everyone knows, so I'm just talking about mostly the chemical soil stabilizations using geopolymer, okay? So you see the failed road, the left side, the pavement due to the weak and highly compressible soil. The common solution is mostly using ordinary Portland cement or lime, but everyone talking about sustainable. So obviously, even the cement production itself, so it generates a lot of greenhouse gas. And although these days people are using calcium sulfur-aluminate cement, so that generates less carbon dioxide while productions. So in US, we have a problem, like a lime sludge that is a byproduct from water treatment plant, and also GGBS from the iron industry, and then also fly ash. So again, the fly ash in US, you have to be used very carefully because of EPA, we need to be a lot of leaching tests if you want to use for any pavement application. So in these studies, basically, this is a part of my PhD students' work. So we used commercially available clay, although it says EPK clay, but it basically is 70% clay and silt, remaining the silt. And we use fly ash, it's a class A fly ash, and the lime sludge and GGBS. and we ground it for 30 minutes and then used it. And then we did some different experiment, most of the cases for UCS test and then also the chemical test to quantify all the different microstructures happened, XRD, XRF, and FTIR. But I'm not going to present all that. So again, also we did some statistical analysis. And then also we discussed the sustainability assessment of this fly ash, lime sludge, and GGBS. So basically, so we tried different combinations. So we tried with the fly ash and lime sludge, or fly ash GGBS is more effective in EPK treatment than individual fly ash and lime sludge, or if the fly ash lime sludge is more effective under, so most of the cases the geopolymer generally used under higher temperature. So we tried with ambient temperature, that's 23 degrees Celsius, and then also we tried with 70 degrees Celsius and see which one is better. And then also we tried multivariate statistical model to predict the UCS, and also we tried and check which one is more sustainable. Although there are different softwares for LCA, but you used the different database and find out which one is sustainable. And then also which one is the fly ash and lime sludge more sustainable than fly ash and GGBS. So basic geopolymer, I'm not going to go in detail. So basically is the inorganic molecule and with high alkaline media is required, and substances rich with silicon and aluminum. That's the one we are using this waste material, basically fly ash, GGBS, or lime sludge. They have a lot of silica and alumina just to utilize that. Instead of dumping to the landfill, why not to use it for salt stabilization purpose? So mostly the geopolymer, you know, the equations are there, chemical structures, but people are using this geopolymer for the concrete, but not many people have studied for soil. So we tried for how to stabilize the soft soil using this geopolymer. So I'm not going to go in detail over here. So basically we need two dissolutions of the amorphous silica, aluminate silicon material. So all the byproduct it has reach with that silica alumina, and then also we use sodium hydroxide and sodium silicate. And then the reaction start, basically the chemical dissolution, chelation, polymerization, and growth, and the geopolymer is formed. So these are the few studies earlier people have done, and then they've mentioned that the strength is increasing. So here in these studies, we did class F and GGBS and lime sludge, and then using 10 molar of sodium hydroxide, and then a certain ratio of sodium silicate and sodium hydroxide. And then we tried to do the life cycle assessment using all these three, pillar for social, environmental, and economical. So, and then finally calculated the sustainability index. So basically this is experimental program, so all the basic tests we conducted, from the physical test, chemical test, mineralogical test, and then you see what happening after these geopolymerizations, UCS test, and also see the microstructures, FTIR and XRD. So these are the different tests. So here, most of the cases, if you see for the concrete geopolymer, I also worked on that earlier, but most of the cases we use a 50 mm by 50 mm cube sample. But this one we use the cylindrical mold dust to see, because the concrete sample, if you'll get the maximum strength how much. But this one we'll get at least we can plot the stress strain graph. So that's the reason we used. And so I'm not going to go in detail over here. So this 10 molar solution we used based on the literature. And then also that the sodium silicate to sodium hydroxide ratio, we used 1.5. Then this is the particle size distribution. As I mentioned, so all this, the EPK clay is, although it is clay, but it is mostly 70% of clay. I'm not going to go in detail, the specific gravity, all the basic tests. So these are the chemical compositions of the fly ash, lime sludge, and granulated blast furnace slag. So the idea is the silica and alumina, that is the main ingredient for geopolymers, so we use that. And then these are the stress strain behavior of fly ash and lime sludge geopolymers. So we tested for 7 days, we tested for 28 days, see how much is the strength gain. So, and I have the UCS results just to show how the stress strain behavior. Sometimes if you see the figure, the second figure is basically at elevated temperature, what is going to happen. So the strength is increased definitely, but at the same time, the behavior is a little bit, brittle. So I'm not going to go. So we combined basically the fly ash and lime sludge. We combined fly ash with GGBS and tested for 7 days and 28 days. So I'm not going to go in detail. So these are, and also we tried ambient temperature. Also we tried very low temperature like a 35 degrees Celsius and 70 degree. Obviously is not much of difference. Obviously higher temperature is higher. The strength is higher. Again, this is for the GGBS. So these are the strength, UCS strength basically for different combinations. And for obviously for 28 days curing, the strength is much higher compared to the normal temperature to the elevated curing temperature. And these are the, again, we calculated the elastic modulus from here, and then also measure the failure strength, but I'm not going to go in detail. So same thing we did for fly ash and GGBS. So most of the cases here we noticed that, so these are the failure pattern, how it looks like. And we did some, as I mentioned, so we did some statistical analysis using ANOVA. So UCS, Young's modulus failure strength, we gave this, and then we calculated the UCS value. And I'm not going to go in detail here. So, and we tried to develop the equation from this statistical analysis. If you know the fly ash content or lime sludge, and dry density, bulk density, and curing time and curing temperature, you can find out UCS value, and the correlation is 0.7, more than 0.7 R-square value. And these are some of the ACM images to see the microstructures. I'm not going to go, obviously, that the strength is more. We see more compact structures to increase. That's the reason the increase in strength. I'm not going to go in detail here. Then I'll talk about a little bit on sustainability, because these days everyone talking about sustainability and resilience. So here, these are the sustainability index we calculated using resource consumption index, environmental impact index, and socio three pillars, socio-economic impact. And then embodied energy here, we use the GREET developed by Argonne National Laboratory. And then also some of the things we need to assume. And then we calculated all these different combinations. So we calculated, as I mentioned, 3 different resource consumption index over here in this table. And so we calculated, you see the A1, the last column. So 1 is basically the lime treated. We compared not the Portland cements, we use the conventional lime. And the second one, the 2 is fly ash and lime sludge geopolymer treated, and the third one is the fly ash and GGBS geopolymer treated. So just compare, so which one gave the best results. For the resource consumptions, here these are the weighted resource values. So from there you can calculate it. Basically we plot a radar chart and then find out the area is less, means that is the sustainability is much more sustainable. So then we calculate the environmental impact index the same way. We can calculate the weighted environmental impact in the last column. And then we calculated for the socio-economic impact index for all 3 combinations, lime and then fly ash lime sludge and the fly ash GGBS. And then finally, the sustainability index has been calculated. And over here, the weighted index for the lime treated is 48. So more number is not good. So for less number is better. So V2 is 12.88. That is basically the fly ash and lime sludge geopolymer treated soil. And the third one is, so both you see the fly ash and lime sludge and fly ash GGBS combinations is much better than the conventional lime. So that is the take out for this. The radar chart, as I mentioned, so here you can see these are the the dotted line is the conventional lime. And then you see the green one is the method B. So we use 15% fly ash and 15% lime sludge. That gives the less energy, less area means it is much more sustainable, okay? So the conclusions, obviously the fly ash and lime sludge-based geopolymer material have successfully used to improve the geotechnical properties of EPK. Lime sludge being a replacement of traditional lime, basically. And so we don't find any studies on the lime sludge and fly ash combinations. So this is so that's why we did that. So mostly the fly ash and lime sludge, 15% fly ash and 15% lime sludge gives the highest value. Obviously, compared to the conventional one, elevated one is gives the maximum value of UCS. Although we are trying, because for the geopolymer, instead of 70 degree, so we are trying to grind the sodium hydroxide and sodium hydroxide and adding water and mix it together, so that, because if you add sodium hydroxide in water, it generates a lot of heat. So we are using that heat so that the geopolymer is formed without elevated temperature. So that's the one that research is going on. And scanning electrons, as I mentioned, so again, so sustainability is the last third point. You see the lime treat is 48.1, and for fly ash and lime sludge is only 12.88. And obviously, this shows that the fly ash and lime sludge is more sustainable alternative compared to the environmental hazard being created, obviously using the conventional is OPC. In US, most of the time people are using, I contacted several companies, they use OPC, most of it, easy, and then also lime. So they don't want to use any other material, so industry people should now use it because this is working, and in terms of sustainability is much better. But again, industry is sometimes reluctant, so again. So these are the work that I presented. The first two papers is going to come, so we already submitted the proofread, so hopefully that's why I put 25, so we don't have, this year is remaining, so, and then another one is basically third papers. And thank you for listening.
Thank you, Dr. Prabir Kole, on the topic, Sustainable Assessment of Geopolymer Stabilized Highway Subgrades Using Industrial Byproducts. It was really informative, and I hope there are definitely a lot of students who are working in this area also. So definitely they'll be benefited. And also you were well within the time. And the sustainability assessment part, which you have highlighted also, because it has been very well taken by the students. And few questions from the audience.
Yeah, for LCS stuff, mostly the people use SIMA Pro and other softwares, but we have just assumed some values and from the data and the grid and others. Yes. Yeah, I mean, so basically the mixing is obviously, in the lab scale it is working. So now we need to try in, the practically how it can be done. I mean, I know that geopolymer, if you think about, I mean, soil stabilization, I don't know where the people are using, but industry are using the geopolymer concrete. In Australia and airport, there are some of the airport they used with high temperature and mixing with all these chemicals and stuff. So same concept. The geopolymer is basically you need to add sodium hydroxide and sodium silicate at certain ratio and then elevated temperature. So yeah, that need to be done in practical scale. So we did it in lab scale. So
okay, thank you.
Any more questions?
Thank you, excellent presentation. But I noticed that you have not spoken anything about the strength gain when you blend geopolymer with, FA and LA mixes.
Yeah, we have that. I mean, maybe I skipped that.
I have not seen much of the curves, that's why.
So there were slides. I mean, there were slides for UCS, how much the strength gain with all the different combinations. We tried with fly ash and lime sludge. We tried with fly ash and GGBS. Everything is there, and that we tried for 7 days curing and 28 days curing, and also we did for ambient temperature 23 degrees, and we did for 70 degrees Celsius, and also some tests we did for 35 degrees Celsius.
Yeah, were there any field trials happened in US?
What is that?
Field trials. Field. Have you applied this in the field?
No, not yet. Not yet.
Okay, thank you.
He was asking also how to do it in practical. So that's one, yeah, we need to check. But it is working, and yeah, for the soil. The concrete it is people are using in practically, I know, in Australia and other places. I don't know about US, but yeah. So everyone wants like a conventional stuff. Like people are reluctant to use the new thing, correct? So.
Thank you, Dr. Prabir, for the
Thank
talk
you.
and the clarifications also. Over to the organizers.
Thank you, sir, for the informative lecture. I request session chair Chhatrapati sir and Cyrus ma'am to please felicitate Kole sir. Thank you, sir. Thank you, ma'am. Now there will be corporate presentation by Terre Army and Ultratech. I request representative from Ultratech to be ready for the presentation.
You can have 5 minutes for your presentation, please.
Terrar. Sorry, you may have to give me a minute. I'll probably have to run like a TJV or a Shinkansen because, we are already short of time. Sorry. Good? Ready? Okay, ladies and gentlemen, a lot of known faces and a lot of unfamiliar faces. I'm going to go straight to the point. By way of introduction, my name is Rohit Thomas. I run marketing for Terra Arme in South Asia. So this is a little bit about the founder when he had this eureka moment on a beach in France when he saw his kids playing with sand. He decided to use, pine needles, and there was born the idea of reinforcement. So just a little bit, and we are actually the pioneers of the reinforced earth technology. We're part of the Vinci Group, which is a huge organization which is in the excess of about 70 billion euros. If any of you invest in stocks outside India, Vinci is a good company to buy. It steadily trades at 103 euros. So just a little bit on the nutshell, we've been active in India since 1996. We've done about 600 plus projects, and we have a couple of manufacturing facilities. And we have one of the finest geotechnical engineers in the country who does a lot of our design. What we do, we primarily do engineering, we do custom material supply, and we do on-site technical assistance. So we're not really a contractor, but we are a very specialized subcontracting company that is in the geotechnical engineering design. So yeah, we do about 17 to 18 odd market sectors. We are basically all over the place in different sectors, with roads, railways taking a lot, and coastal and environment gaining a lot of traction. The 4 business lines, one is based retain, it's cross, it's protect and strengthen. One talks about the MSC walls, the other one talks about precast structures, the third talks about protecting structures, and the fourth talks about strengthening structures, which is more of basal reinforcement and geosynthetics. These are a few examples of some walls that we have built, and for your example, we also work very closely on the waterfront reinforced earth walls with steel fascia. few examples of the reinforced soil. The other one is the TerraLink technology, which was earlier referenced, which is a shored or a composite reinforced earth structure. This is basically two examples from J&K and Himachal, where you have the reinforced soil slopes with mineral fascia and the green fascia. These are a few examples of structural things that we do, basically your cut and cover structures, arches and boxes. We do a lot of work for environmental protection using geosynthetics. We use erosion control blankets. We are into slope protection, and we do slope stabilization as well. This is another interesting thing that we have worked, and this is really a product of the future. You're most welcome to come to S23 and take a look. It is extremely good for riverine, coastal, and the tank bund protection. It's made of geosynthetics. And the best thing is you can do installation of this in an underwater setting without any dewatering. Yeah, as usual, this is another thing that is gaining a lot of importance. The central government and a lot of state governments are pumping a lot of money into protecting assets and people. Sorry, not my fault. Sorry. Yeah, so this is one thing to note is that we are the only company in India that engineers and sells rockfall barriers that are ONR 24810 and CC class certified. We are into high strength basal geogrids called Armalink, which is another unique, which is up to 1800 kilonewton per meter, which is something unique that we have. So this is good for soils where places where soils are not exactly very great, and you can use them for hard stands and things like that to improve the condition of the soil. Drain tube on the right is another innovative product that we have. It is on display there. You can come and take a look at it. It's extremely important in the current scenario. This is an interesting thing, and it comes in these layers, and it is very light and flexible product, and there is no peel adhesion issue. It is primarily used in civil works, in mining and energy, and environmental applications, and sports field. This is a signature project. I'm not going to brag about it. I think many of you know about it. And we are actually certified as we built the world's tallest reinforced earth structure. And we built this using the TerraLink technology, which is again a shored or a composite reinforced earth structure. And the beauty of that is we take care of the green ambitions very closely, and we even continue to provide a lot of safe drinking water to about 30 plus households. It's in West Bengal, so if you ever go to Siliguri, it is not very far from there. It's close to the Darjeeling toy train area. So, many people, a lot of accolades have come from CEAI, from ASSOCHAM, and, we really hit the nail on the thing when we got the Limca Book of Records that was certified. And yes, like I said, we don't really greenwash. We are actually acting, we are optimizing, and we are preserving. So I have all the data. If you want what kind of calculations we do, please get in touch with me. I'll be happy to do it. So this is, so just to sum up and just to give you a quick idea. So we are a top-to-toe solution provider, right? Right from the hills up to the coast, you name it, we have the solution. So we are highly specialized, but we have all these solutions. Please feel free to come back to us. This is another question I want to leave you. When Andre Vidal had that eureka moment, now the question is, have you all had that eureka moment? It may not be applicable to people in the front, but I see a lot of youngsters who are very keen. So think about this. Your idea for a minute may change the entire world. Please come to S23 and take a look in whatever time that you have. Thank you.
Thank you, sir, for such a nice presentation. I request session chair to please felicitate sir.
I was under time.
Thank you for that.
Thank you.
Now I request representative of Ultratech to please start the presentation.
Yes, thank you, ma'am. Yes, I will complete within 5 minutes. Yes. Yes, thank you. Myself Vivek Sonjay. I will be here presenting for corporate of Ultratech Group. So our mother group is ABG, Aditya Birla Group. This will be a success story of our Aditya Birla Group with having a legacy of 163 years over a branch of 42. We have grown from 8 nationalities to 42 nationalities, from 8 countries to 36 countries, and we are proudly to say the part of Fortune 500. Next, as previously you will be thinking, when Ultratech is coming in mind, then picture of cement will be there. But now onwards, there are 5 verticals which we are dealing with. First one is Ultratech Cements. It is titled as India's largest cement selling brand. Next is Ultratech Concrete Solutions. This is the first RMC players in India having 100 plus plants with 29 products. Next one is the building product division, where we are having a 28 ready-made solutions product for repair segments, dry, liquid, and AAC blocks. Next one is a building solution where we are trying to give a customer offering 35 plus products and 7 plus services along with 10 plus solutions at under one roof. Next one is we are having a Birla White segment where we are providing a white cement and cement-based putties. Next one is Ultratech Cement. It is related to our vision to be the leader in building solutions, along with a mission of to deliver the superior value to the stakeholders on these 4 parameters, including sustainability, innovation, customer centricity, and team empowerment. As you all know, we are having India's largest capacity with 119 million metric ton. We are targeting by up to 200 million metric ton by 2026. These are our some valued customers we are working with, and these are partnering with national projects like a Statue of Unity, Gujarat. Next one is Atal Tunnel, Motera Stadium from Gujarat. And also we are partnering with some projects like Metro Rail, airports, roads and bridges. And these are some ongoing and futuristic projects we are having. As I already mentioned, we are having a building product division which will consist of industrial grouts, repair segment, floor screed, plasters, waterproofing agents, AAC block, tile adhesive, and mortars. And next one will be, this is a pictorial representation where that products can be applied. And this is whatever products we are providing, all products are certified by IGBC, Indian Green Building Council, and all teammates are there to provide you a solution on the basis of demonstration, whatever products you require. This is RMC-based products which we require on landscape, flooring, structural, superstructures, and substructures. And also for small customers who are building their home at their self level, we are providing these on-site consultancy services for them. This is our door-to-door service. Thank you.
Thank you, sir. Now I request session chair to please felicitate. Now I request Dr. Samadhya sir and Kulkarni sir to please felicitate our session chairs. Thank you, Chakravarti sir. Thank you, Cyrus ma'am. Thank you, Kulkarni sir. Thank you, Samadhya sir. Thank you. Now I welcome Jain ma'am and Dr. Samadhya sir. The next lecture is on challenges faced in underground tunneling works by Dr. Atul Gadgil sir. I welcome Dr. Atul Gadgil sir on stage. Before starting the lecture, I would like to give brief introduction about Dr. Gadgil sir. He is BTech in Civil Engineering from IIT Delhi, MTech from IIT Delhi. He is Director Works Maharashtra Metro Rail Corporation Limited, work as Assistant Executive Engineer in Central Engineering Services, work as Executive Engineer in Central Engineering Services, work in Delhi Metro Rail Corporation as Deputy Chief Engineer, planning and construction of Khyber Pass Depot for Line 2 and Nazafarga Depot for Line 3, Delhi Metro Phase 1, construction of 7-kilometer elevated viaduct, work as Chief Project Manager in 2010 to 2018. His director works as Director Maharashtra Metro Rail Corporation Limited. Now I request Dr. Atul Gadgil sir to please start the lecture.
Okay, before I request Dr. Gadgil for the presentation, I request all those who are sitting outside the Manthan Hall, if you are hearing, please come in the Manthan Hall. There is going to be a very important presentation by Dr. Gadgil about the metro. So I request all those who are sitting outside the Manthan Hall, please come inside. Okay, sir. Thank you.
Good afternoon to all. A small correction, I am not Dr. Atul Gadgil. I am not that fortunate. I am just Engineer Atul Gadgil. Just a small correction. Right at the outset, I thank the organizers, IGS and MIT, for inviting me here in this wonderful setting and giving me opportunity to showcase our Pune Metro work. I'll be speaking on this. This is the outline. Since I represent a metro fraternity, I must tell why metro is now needed. It is a necessity as it become in tier 1 and tier 2 cities. Then I will be digressing slightly to showcase my Pune metro project. And then coming to the main topic of today's, that is underground challenges in the underground structure, underground construction with building condition survey, instrumentation monitoring, geology of the project, and tunneling methods. Since I represent metro organization, there's a genuine question why metro is needed in India. See, we are progressing at a very fast pace and our cities are really growing up like anything very, very rapidly. There is huge load on the infrastructure and literally in tier 1 and tier 2 cities, the road network is crumbling to sustain to the growing needs of vehicles. So metro is coming as a solution for the public transport system and already proved in Delhi in tier 1 city, and now it is growing. Almost now 15 cities are metro is either under construction or they are aspiring to construct metro. Government of India has issued an advisory that whichever city's population is having 10 lakhs, they should start planning metro rail, any sort of mass rapid transport system, be it metro or BRT or any other system. And by the time it reaches 20 lakhs population, the public transport system, MRTS, should be in place. Just a case of my city, Pune, the population has now reached almost 1 crores, but we started very late. We started planning the metro actual construction in 2017. Better late than never, but yes, we have completed 33 kilometers of network. Now it is running successfully. Talking of your city, Aurangabad, Maha Metro has prepared a DPR for Aurangabad as well, because now the population, as per last available data, is about 18 lakhs. So we have planned a metro network here of about 40 kilometers. Aurangabad Municipal Corporation has already approved it, and it is with Government of Maharashtra for further sanction. There is some technological issues involved here because we have proposed a new concept of Metro Neo because it is regular metro will not be viable in Aurangabad city. There are certain direct and indirect advantages of a metro system. The direct advantage is that it is the most energy efficient system of public transport. It consumes only 1/5 of the energy per passenger kilometer compared to road-based system. It absolutely causes no air pollution. There is very, very less noise pollution. And the beauty is that it occupies really no space. If it is underground, absolutely no space. And if it is overground, just the median is required to construct our pillars. So there is no load on the additional load on the existing road infrastructure, and we can carry a lot of passengers on our system. To give you data, it carries equal traffic as 5 lanes of bus traffic and 12 lanes of private cars. It is more reliable, comfortable, safer than road journey, and the transit time is reduced by almost 50%. I'm a bit digressing from the main topic, but I want to showcase whatever we are doing in Pune. These are the tangible benefits, but there are huge intangible benefits in terms of increased productivity due to less travel time, saving in vehicle operating cost, savings from accident reduction, savings from pollution reductions, and reduced road stress and a greener environment. So we are contributing in almost every field. This is just a diagrammatic view of the Pune, which is expanding in all the radial directions. So we have planned metro in all those radial directions and then the circular routes. Just a brief overview of Pune Metro. First, about my organization, Maharashtra Metro Rail Corporation Limited. It was founded as Nagpur Metro Rail Corporation in 2015. But when Pune Metro was also constituted, it was rechristened as Maharashtra Metro Rail Corporation. It's a 50-50 JV between Government of India and Government of Maharashtra. Maybe very few people of you may be aware of this 50-50 concept. It is the brainchild of Dr. Sridharan, who is known as father of the metro, who successfully started the Delhi Metro Corporation, and now it is spreading all over India. So the beauty of this 50-50 concept is that both state government as well as central government, they treat metro as their baby, and we get all the help from both the governments, irrespective of the political situation there. So that is the USP that all the metro organizations are flourishing in this country. More so, the local government, that is PMC in our case, their commissioner is also on our board, so we get all the local help as well. So that is one of the very beautiful idea Dr. Sridharan has set up in India for all the metro construction. In the last 7 years or so, we have already completed Nagpur Metro Phase 1 for 40 kilometers, Pune Metro for 33 kilometers, and SIDCO for 11 kilometers. Few projects have already under progress. Nagpur Metro Phase 2, Thane Metro, and recently Pune Metro has also get few lines of extension. Just a brief overview of Pune Metro line. Whenever a new metro line is planned in any city, it is traditionally in the plus shape, so that north, south, east, west corner of the city is covered. So same thing we have planned here. Out of this 33 kilometer, 5 kilometers is underground. The project cost is about 13,000 crores to be implemented in 4 years. So you can imagine how every year we are spending a huge amount right in the middle of the city. And Pune has never experienced such infrastructure work, huge in terms of cost till now. Just as we completed Phase 1, extensions have been granted. North extension 5 kilometers, and south extension, it is again underground from Swargate to Kathraj. The work is in planning stage. North extension work has already started. But we are not stopping here. Now, apart from the radial directions, we are now having circular routes also. So about 160 kilometers of metro network is planned in various phases, and about 80 kilometers is in advanced stage of sanction. As I said, about 15 cities in India has either metro already running or under construction. So when we were planning metro, we thought of that we should be looking something different than the normal metros. So all our stations we have designed as theme-based stations. So just the glimpse of a few stations which are becoming landmark in Pune, like industrial theme, this is the VADA theme, this is the organic theme, This is the famous station at Yerwada, which depicts the Mahatma Gandhi's Padayatra. The left corner is the reel theme at Null Stop Station. The old concept of that reel, it is now no more, it is now digital, but we have depicted that in one of our stations. One of the rightmost station is iconic stations. It is in the shape of Tanaji Malusare. We are still struggling to complete it because of the typical shape. These are some of the underground stations where only entry structures come up. Some interiors of the interior station. Two pedestrian bridges we are constructing at those iconic stations. One is with Tanpura shape and other is also some musical instrument shape. Apart from this typical themes, we are some unique initiative we have taken. Two of our metro stations have been constructed with NATM technology. The entire station has been with new Austrian tunneling method technology. Almost I can say it is the first time in India. Other locations, some cut and covers and some crossovers locations NATM has been used, but here because of the congested locations we could not find any space, so we went for NATM technology. Iconic station design I have already told. That municipal, one of the site was municipal garbage site at Pune, which was offered to us as depot land. So there about 5 lakh cubic meter of municipal waste we could remove from there, and out of that 2 lakh cubic meter we retrieved for our backfilling purpose. So we coined a word Kacharai se Kanchan Tak, and it has been used at many places by our Honorable Prime Minister to whenever he refers Pune Metro at his other inauguration speeches. Then some multi-layer transport system. We have constructed a double deck at Null Stop with elevated road at first level and metro at second level. And now this double deck system is picking up. In many cities we are now having double deck structures. We started first with Jaipur, and then now it is Nagpur, Pune, and all other cities, double deck structures is coming up. All our stations will be IGBC rated. 100% water cycling, that is one of our USP, that we are not allowing any drop of water to go into waste. Either it is being recycled through STP, we again recycling on when the water quality deteriorates after number of cycles, we are using it for horticulture purpose. No tree cut policy is another USP of our Pune Metro because whenever there is a development work, trees come across the development, our alignment. And there is huge hue and cry, and especially in Pune city where citizens are very agile and very alert that they oppose like anything. So we decided that none of the trees will be cut, all the trees will be transplanted. We did it with full sincerity, and I am proud to say that about 75% of the trees survived. So we got a good feedback from everyone, Puneites, and absolutely no opposition on the tree issue. Then we are the first to use the aluminum metro coaches. Then solar power we are harnessing in big way. National compliant mobility card and 5D BIM. This is the last is very important, that all our designs and drawings are on now digital platform. Although it is a transition phase, so we are maintaining hard copies also, but everything is on our digital cloud. First mile and last mile connectivity, very important to increase our ridership, to make ourselves viable. There is a policy that from your household, every metro station should have at least connectivity by way of cycle, e-bus, etc. to reach to the nearest station, and then from destination station to your point of work also. So we are into big way in providing first mile and last mile connectivity to increase our ridership. We are into a service sector, we are not profit oriented, but government has given us a mandate that you should be standing on your own and you should not depend upon government funding. So there are huge initiatives to garnish non-fare box revenue. So almost only 40% is from fare box, rest is all from the non-fare box revenue through these measures. I will not go into details as it is not the main topic. Now coming to the main topic of underground construction. I understand many of the previous speakers were from academic field, but now what I am going to present to you is how the state-of-art technology we have used to construct the Pune Metro project, and especially the underground section. This is the alignment of underground section in phase 1. It is 6 kilometers from Sambhajinagar District Court, Budwarpet, Mandai, and Swargate. This is a Google image. You can see how dense it is. So there was no question of planning an elevated section here. So we have chosen the underground option. And this is very important at the time of initial planning, that what should be the route of the underground section. So we try to maximize, put our alignment below roads as far as possible, although roads are narrow, but there are no buildings over it. But yes, we can see there are a number of buildings we have cut across that. And then the stations are located in such a way that only government land is required, is chosen. And because private land displacement is really very, very big challenge. Once the alignment is finalized, the use of TBM, how TBM is to be planned, that is another important aspect. So this is just a linear presentation of we have divided the 6 kilometer into 2 contracts. So this is the linear representation of the first contract. As the elevated line goes into the underground, so there is a cut and cover ramp, open sky covered ramp. And after that, there is a shaft constructed to lower down the TBM. And from there, tunneling activity is started. It cuts across the stations because every 1 or 1.2 kilometer you will have a station. So this is the TBM lowering. Then TBM drives. It goes on mechanical way, excavating and liner. I will come to that later on. Then once you come to the station, then there are 3 ways. The traditional way is that at the end of the station, you take out the TBM and then relaunch at the other end of the station. That is, if the station construction is synchronized with the tunneling activity. If there is a delay in station construction, then there are options that we can either drag through the TBM if the base slab is ready, or if nothing is ready, then we can drive through the stations and later on do the station construction. So this is once we cross the Sambhajinagar, again the tunneling drive starts. It goes to civil court, and then at the Budwarpet, both the TBMs are retrieved. Similarly, in the, this is just data, the total 4.2 kilometers of bore tunnel, and there is a NATM crossover to accommodate the rail crossings. This is the next contract, again linear description. Similar way, TBM lowering at one end, and then drive through the stations, and then taking out TBM at the other end. Before any construction activity is started, especially for the underground work, building condition survey is the very, very important aspect. What we do in the influence zone of our tunneling and station work, we have to map each and every building. We have deputed teams to visit the building and meet the household, every household, and then map the entire condition of the structure. So few instruments also we installed. I will come to that later on. So the zone of influence is 50 meters from either side of the tunnel and twice the depth of the underground stations. That is the influence zone within which every building, every nook and corner has to be mapped. So this is a graphical representation. This is a tunnel section, about 50 meters on both sides, and about double the depth of the station. We have mapped all the buildings. And then after mapping all the buildings, categorization is done based on the number of cracks the building has and the severity of the cracks. So all the buildings are designated from negligible to very severe. Some of the examples, the left side is very slight damage, then slight damage, moderate damage, severe and very severe conditions. These buildings are over 70, 80 years old building. We faced a lot of challenge during this process because the households were not ready to cooperate. They were not allowing us to enter into their houses. We tried to convince them. This is the tool they use so that later on they will blame the metro sector that because of your construction our house has got damaged, and then they want compensation. And it turns into huge compensation. So we were careful. We tried to map their houses, and if they were not receiving those data, then we have sent it by registered post also. So our data is very intact, and we did not face any problem later on. Few isolated cases are there where they tried to put the blame on metro, but we could show them, yes, the cracks were there before we started the work. Just to give you an idea that more than 1,500 buildings we have surveyed. These are the buildings that all buildings are having number of floors, rooms. So every nook and corner has been. So we have got a huge database of all the damages before start of the work. So after that, the real engineering starts. We have to draw contours all along the alignment, settlement contours. Because of the tunneling activity, there will happen, there has to be some settlement. So it is first predicted and drawn along the alignment, so that is called settlement contours. And if the settlement, predicted settlement is less than 10 mm, and the ground slope, because ground slope also plays very important role, is less than 500, then there is no chance of any damage to the building due to the tunneling activity. So in the next stage, out of those 1,500 buildings, some buildings get filtered out. Remaining buildings come under building 2 assessment, where the tensile strain, because of the tunneling activity, there will be settlement and stress will be generated on the foundations. So if the tensile strength is below, strain is below 0.15%, again there is no need to worry. Those buildings will be safe. So this is another filter criteria to remove a few more buildings which will be safe. And the stage 3 building is the real buildings which we have to monitor, continuously monitor during the construction period. So this is just a example of, we have drawn the contours of having 5 mm, 10 mm, 15 mm settlements. So these are the contours, then we can find which building is lying in which contour. So after that, those building again has to be reclassified in terms of damage category. Then B1 is, after the stage 3 assessment, those buildings only needs to be monitored in this way. If it is, damage is negligible, then it needs only periodic monitoring. If it is slight damage, then regular monitoring. And the last category is very severe, where we have to do some protective measures and round-the-clock monitoring is required. So now instrumentation, these were the buildings which we identified for doing the monitoring. And then by way of instrumentation, these are the parameters on which we have to monitor the building. That is tilt and rotation of the building, cracks, settlement of the building, deformation in 3 dimensions, vibrations, and monitoring of the groundwater. Because of the tunneling activity, groundwater draws down. So that will have some adverse impact on the foundations. So all buildings are monitored in that way by way of instrumentations. And then there is a robust system of reporting by the contractors to the engineers and engineers to the clients, that is Mahametro. I will tell you in the next slide. Vibrations is a very important aspect, because either you do blasting or you do tunneling, there will be vibrations generated in the ground, which will travel to the foundations at the subsurface level. And buildings, we have categorized the buildings in terms of the peak particle velocities, that is the measure of vibrations. So if the building is in very good condition, it can sustain 25 ppb. But poor conditions, like those risky buildings, only 5 mm peak velocity will be permitted. Any heritage structure or infrastructure buildings will also be limited to 5 mm peak particle velocity. As I said, various parameters. There is a limit which is called alarm level. So it is predefined, those alarm levels for the vibrations or settlements or tilts. So whenever that, by way of monitoring, we find that the parameter has reached to the 50% of the alarm level, an alert will be generated through mobile and through mails to the field engineers down below. And they will now be sensitized to be careful for further work. If the deformation continues and reaches up to the 70%, then immediately all the surroundings will have a close monitoring to see and engineers will try to find out what is the root cause. It is still, if doesn't sustain, doesn't stop and reaches the alarm level, then immediately all the activities are suspended. All the works are stopped as it is various basis, and then we try to find out the root cause and address them. So these are the parameters and the limits: alarm level, action level, alert level. And I am very proud to say that in our tunneling activity of 6 kilometers, none of the buildings got damaged, and people were very apprehensive initially. We got a lot of opposition, but because of our very scientific way of working, none of the buildings got damaged. These are some of the pics of the instrumentation, settlement points, inclinometer, crack meter. Not only the existing buildings, but our own buildings, that is the new buildings, whether it is a tunnel or structure, that also we keep monitoring to see that whether any deformations are there in the newly constructed building as well. So these are our retaining walls. There also we have put the instrumentation. This is the NATM section. Here also the extensometer, pressure cell, load cells, all type of instrumentation we do to see the stability of our structure. And then those monitoring the buildings, all the instruments, some of the instruments, the data is recorded daily, some are recorded weekly. This is the schedule which our engineers follow. Now coming to the geology, because any underground works, first the geology has to be studied in very, very great detail. So luckily in the Pune, we are having all the compact basalt structure anyway, because we are about 25 to 30 meter below the ground. So they're all, either it is a compact basalt or a amygdaloidal basalt or vesicular basalt. So it is a sort of boon for tunneling activity, because tunneling in soil is much more riskier than tunneling in rock. Although time taken in rock is more, but it is less sensitive to vibrations and settlements. So we did boreholes at every 50-meter interval all along our tunnel. We went up to about 30 to 35 meter deep. We have preserved all those these rock columns, and we did the
Last 2
engineering.
minutes, sir.
Just quickly. There is a video for our TBM activity for 5 minutes. I will quickly cover all those things. Then all the rock category is mapped as soft weathered, medium weathered, heavily weathered. Then permeability is also very important, because during excavation, a lot of water seepage is there, so we need to control it. This is the profile along the length, we map it. Then coming to the tunneling method, there are two methods generally used for metro construction. The first one is New Austrian tunneling method. The name is New Austrian, but it is a traditional way of doing, wherever cut and cover is not possible, there we do NATM, and in road sector it is being used mostly. TBM is the state-of-art technology mostly used for metro sector. It is a totally mechanized way of constructing, very fast method of doing tunneling. Just a quick review of the NATM. This is our typical profile for the NATM cross-section. We divided it into a number of segments. Top heading also is divided into 3, and the benching. So excavation is done stage by stage. First the top heading, then the top heading 2, then top heading 3, and ultimately do the benching. Even in, and then the lining, that will come later on. When we start the work, first we do the survey, then we do the drilling and blasting. This is also a very important aspect. Blasting is in itself is a science. We have employed consultants who have studied the geology, and they have given us how much charge is to be provided, what will be the spacing of the holes, depth of the holes to do the blasting, because it creates vibrations. And I have already told you that we have structures above. So some are risky structures, some are sound structures. So based on that, the consultant gives us the drilling methodology. With that, we do the drilling, blasting, removing of the muck, and this is the cyclic process which go on for NATM construction. And within the top heading also, there will be a stagger. The top heading 1, the top heading 2, and top heading 3, there will be a stagger just to make the section stable. So here we have maintained a stagger length of 14 meters, but it can range from 10 to 20 meters as well. Then after the construction excavation is over, then it is to be stabilized by way of soft lining and permanent lining. So I'm not going into the details. These are the just a cross section, the edge of the cross section, then shotcrete layer of 300 mm and a permanent lining of 450 mm thick concrete. Despite taking so much of precautions, we came across few surprises during our NATM activity. At one of the locations, we came across a huge cavity Above the top heading, there was a natural cavity. It was a natural cavity of about 6 meter by 7 meter and 2 meter. So the problem was that cavity was increasing slowly and slowly. And there was a lot of water seepage from there. So it was a huge task to close this cavity. Otherwise, it would have become unstoppable and entire our project would have been at stake. So we stopped all other activities and we tried to plug this hole. So this is a view of that cavity. It looks small, but it is very dangerous if we don't take timely action. So this was the cavity which we, by stopping all other activities, we plugged this cavity by way of rock bolts and shortcut layers. So it took almost about 2 months to close this small cavity because continuously either water was seeping or there was some, the cavity was expanding. This is just a cross section of that. Now coming to the TBM, that is the mechanized tunneling. These are the steps. First we have to design the TBM, which type of TBM to be taken. Then is cutter head to be designed. Then this is the launching shaft. This will be covered in that short 5 minutes video, so I'm just skipping this. These are the pictorial presentation of the tunneling activity. First, TBM is assembled at the launching shaft level, then it is lowered from the launching shaft, then you start the tunneling activity and at the retrieval and shaft you take it out. These are the views of a TBM, typical TBM. I am just skipping this because there is a 5-minute video which will be self-explanatory because of the short of the time. These are some views and now this is the video. I would like to play this. Just 5 minutes video, I hope that much time is there. Sound?
Ground conditions for projects around the world, including soft ground. One of the most popular TBMs is the Earth Pressure Balance, EPB, which is suitable to excavate in soft and mixed geologies for tunnels constructed under the city.
Most widely used is EPB.
In cooperation with Japanese manufacturers, TerraTech has developed an EPB tunneling system, which is one of the most reliable and efficient in the market today.
It's a huge machine, about 250 metric ton and 70 meter long.
The TBM is divided into two main parts. One is the shield, which is in direct contact with the soil and the excavation face, and isolates the interior of the machine from the ground with a steel skin. The other main part is the backup system, which is a rolling structure that follows the shield and which carries all the auxiliary systems to allow the continuous advance of the TBM. On the front of the shield, a cutter head equipped with its cutting tools rotates and excavates the ground from the tunnel face. TerraTech's cutter heads are designed specifically for each geology, and its cutting tools configuration and opening ratio depends on the project needs. The cutting tools consist of blades, which tear the material from the face when the cutter head rotates, and scrappers, which convey the excavated material to the muck chamber. For those sections where the ground is competent enough, TerraTech's cutter heads can mount roller disc cutters instead of the blades. These can be easily replaceable from behind the cutter head when required. TerraTech's own designed backloading disc cutters can be single, double, or triple, in sizes which range from 13 to 19 inches. The disc cutters can be monoblock or ring replaceable type. Depending on the geological conditions, the most suitable combination of disc cutters is selected. When the ground conditions require it, water, foam, or additives can be injected through multiple points on the cutter head, giving to the tunnel face more stability and allowing a smoother material flow. minimizing the wear of the cutter head structure and the cutting tools. The cutter head structure is supported by a large 3-row roller bearing, and the rotation of the cutter head is produced by the action of several electric motors driven simultaneously. The advance of the EPB TBM is produced by the action of the thrust cylinders. These cylinders are mounted in the rear section of the shield body and react against the tunnel lining, transferring its pushing force to the cutter head and allowing the TBM to keep advancing. When the tunnel alignment requires the negotiation of curves on the way, the shield body may be divided into 2 sections, front and rear. In this case, both sections of the shield are connected by hydraulic articulation. This articulation transfers all the pushing force of the thrust cylinders from the rear body to the front one, allowing the thrust cylinders to keep pushing evenly through the
Underground
segment
alignment
lining.
is never straight, it always have curves. So this is a very useful tool. With the synchronized use of the jacks, we can maneuver the
The
movement of the
installation of the
TBM.
tunnel lining is produced by the erector arm, which is located in the rear body of the shield. Once the TBM has completed the excavation of one full stroke,
The excavation is done ring
the
by
thrust
ring.
cylinders retract in
One ring
groups,
is about
and the
1.4
erector
to
commences
1.5
the
meter width.
installation of each concrete piece, which are known as segments.
So everything is automated.
The erector takes each of the
Typical
segments from
ring
the
is having
segment
7
feeder
segments. All
and
the segments
places
are
each one on its position
fixed to
until the
its
last
proper
one,
location with the
called
use
key
of this
segment,
jack.
which closes the ring and allows the TBM to commence another boring cycle. In this way, the TBM installs one ring after another, allowing the tunnel length to increase until the complete tunnel is finished. The evacuation of the excavated material is done through a screw conveyor. From the screw conveyor, the material is transferred to a belt conveyor in the backup. And from there, it can be dumped into muck cars or into another conveyor installed on the tunnel wall. The tunnel conveyor, which extends continuously as the TBM advances, is the preferred solution, especially for long-distance tunnels where this method is much more efficient than the conventional evacuation by muck cars.
The system is so mechanized
The
that only
segments and
about
other
5 to 7
supplies which
persons
allow
are
the
required in
advance
a
of the
team
TBM
to do
are
all these
transported
activities.
to the
Rest
TBM
everything
by
is
the
mechanized.
supply train. This train typically comprises of a locomotive pushing 2 segment cars, a grout car, and platform to carry other materials. In addition, when the evacuation of the muck is by the train, several muck cars must be also included in the train. When the train arrives at the backup system, a crane picks the segments up one by one and carries them to the segment feeder. The segment feeder forwards the segments sequentially one by one up to the erector. Depending on the size of the TBM, the capacity of the segment feeder can be for half or for one complete ring. During the segment unloading operation, all of the materials from the train are transferred to the backup system. Once all the supplies from the train have been unloaded, this departs from the backup, allowing the next one to come in. TerraTech EPB tunnel boring machines provide the most advanced design and reliable technology to allow the efficient excavation of kilometers of tunnels in any type of soft or mixed ground.
Thank you very much for your patient hearing. Next year, our new project will start where tunneling activity, we hope by end of next year it will start. So all of you are invited to see the actual operation of the TPM machines. Thank you very much.
Thank you, sir, for the nice presentation. Since we are running out of time, we are late. So if you have any question, you can, no, not now. You can contact him and then discuss during the lunch. Thank you, sir. Over to organizers.
Thank you, sir, for an excellent presentation. Now I request Dr. Samaria sir and Suman Jain ma'am to please felicitate Gadgil sir. Now the next will be corporate presentation by Geotech and A&T.
I request you to please complete the presentation in 5 minutes.
Yes, sir. Good afternoon, everyone. Gunjan Disawal this side, Vice President Sales and Marketing at Geotech Industries. I'm present here on behalf of Geotech Industries. Thanks for my presence in IGC, and thanks to the organizers. Geotech Industries is established in the year 2020 with the production facility area of 1 lakh square feet and having the 99% on-time delivery rate of the products which are PP biaxial geogrids and HDPO GSLs. Currently, we have the huge client base globally as well as domestic, and we deliver the cost-effective, efficient products for the infrastructure and environmental projects. We have some technical supports as well, as and when required for the projects. We have the vision to be the biggest and the largest manufacturer of the PP biaxial geogrids and the geocells, which are used in the infra projects, having the sustainable solutions, and as well as thinking the approach of the client-centric. We have the quality products. The basic understanding, the usage of these products are for the soil reinforcement and stability requirements whenever there are some issues in the reinforcement. When there would be some pavement or road failures, at that point of time we can use these two products. As well as we can use the products for the uneven load distribution in the soft soils. These are the basically two products what we are currently manufacturing and expanding day by day. One is the PP extruded geogrids. We are the largest manufacturer in India of PP extruded biaxial geogrids and the HDPO geocells. These two products are cost effective. They reduces the material usage, the conventional material usage which are required in the pavements and the highways, and they are very easy for the installations, which help in the speed of the project timelines as a whole. The key features of the PP biaxial geogrids, if you can see, we have the 24 million square meter annual capacity for the production of the PP biaxial geogrids.
The key features includes of usage of these products are it has high tensile strength, it is flexible, it is chemical resistance and as well as cost effective as compared to the conventional methods. With the different requirements, we have different aperture sizes, different tensile strength ranging from 20 to 40 for the PP biaxial geogrids. It has a high UV resistance parameters and excellent chemical resistant properties. This product we can use for the subgrade stabilization, for the reinforcement on the GSB layers, land reclaimed areas, national highways, landfill areas, and as well as for the landscaping to increase the reinforcement at the subgrade layers, GSB layers. This is the second product which we have the current capacity of 1 million square meter annually with all the different types of width, depth and thicknesses from 1.2 to 1.6 and it can be increased. The key features of the HDPE geocells are improved load distribution, erosion control, they are durable and versatile. We manufacture the geocells with the HDPE with the cell depth of 75 mm to 300 mm. They are also UV resistant and chemical resistant properties. The application areas of the HDPE geocells would be subgrade stabilization, reinforced of the steep slopes, score protection, container yards, landscaping and national highways. These are some of the product certifications we already got that are both the products are BIS certified, ISO certified and these all the codal provisions which are given under the IRC and IS pertaining to the PP biaxial geogrids for the flexible pavements and as well as the geocells for the slope protection and the base. These are some of the pics of our manufacturing area as well as the laboratory. Any questions?
Thank you for managing within 5 minutes. Thank you so much. Over to organizers.
Thank you, sir. Now I request session chair to felicitate sir. A&T representative from A&T are requested to please come on stage for the presentation. A&T. Thank you, sir. Thank you, ma'am. Now, the next keynote lecture is on challenges in construction of underground Pune Metro Rail project by Dr. Keshav Taide sir and Jain sir. Before starting the lecture, I would like to give brief introduction. Dr. Keshav Taide sir is B Civil, MTech, IIT Powai, LLB and PhD RTM Nagpur. Joined WRD in 1985 through MPSC, work on Pench Hydroelectric Scheme, work in quality control as principal of Regional Training Center, working in Maharashtra Rail Corporation for more than 8 years as General Manager, 22 papers published in international and national journals. He is Secretary of Engineers Forum Nagpur. He was Vice President of Indian Concrete Institute Chennai, member of BIS, Board of Studies for Civil Engineering Nagpur. Rajesh Jain sir is BTech in Civil Engineering from VNIT, postgraduate diploma in project management from NICMA Pune, work as additional chief project for Maharashtra Metro Rail Corporation Limited Pune, principal consultant in Beaver Infra Consultant Private Limited Navi Mumbai, project director for NEF Railway, Chief Project Manager in SAI Consulting Engineers Private Limited, Ahmedabad, Project Manager for Larsen and Toubro Limited, Deputy Chief Engineer in Konkan Railway Corporation, Belapur, Navi Mumbai, Regional Controller of Stores for Konkan Railway, Assistant Executive Engineer, Inspector of Works for Central Railway, and Resident Engineer for Gajaraj Builders Private Limited, Nagpur. Now I request Sir to please start the session.
Yeah. Good afternoon, everybody. I am Dr. Taide, and with me is my colleague, Engineer Jain, and we both will be presenting about the part 2 of the presentation of underground metro, Pune Metro Rail. Our director has already thrown light and have explained you the various aspects of tunneling, and we will be talking on the underground stations construction. This is the bird's eye view of the civil court station, and you can see the Metro Bhavan and the underground station. After it is fully covered, you can see only the top portion, and I'll be deliberating on how it is constructed. The topics are the introduction, the geology part sir has already covered, and it's a station construction by cut and cover method I would be covering, and the NATM sir has also done something, but I'll be throwing a light in some details, and there are then major engineering challenges. This is the route map known. 2 metro corridors, as sir has already explained, and 5 underground stations are there, namely Sambhajinagar Civil Court, now called as District Court, Budwarpet, Mandai, and Swargate. The geology of the project, sir has already covered. These are the geological sections along all these stations, Sambhajinagar, then Civil Court, Mandai, Budwarpet, and so much in details that it's very difficult to explain here, but we go very much in details where the huge amount of records we are maintaining. The key activities involved are these many. It starts with topographical survey, and then the layout, one of the part, and then it ends with safety certification and technical clearance by the CMRS before route is taken up for commercial runnage. This is the stations are trench method or cut and cover method, and the NATM, and use of tunnel boring, sir has already explained. So I request Jain to continue with cut and cover method and come back with the NATM.
Good afternoon, everybody. I will be talking about the excavation of the underground station. So the one method is the cut and cover method. In cut and cover method also there are 2 methods. One is the bottom up method and one is the top down method. Most widely used method is the bottom up method, where we get the entire length of the station and areas available to us, so that we can have a luxury of excavating the entire area and hold it for a period of around 4 years, because that is the normal construction period for an underground station. In top-down method, first we construct the retaining walls in the form of by making a diaphragm walls. Then after making the diaphragm walls, it is secured by installing the top whalers, and the excavation is taken up. Gradually we make a top slab, then further we excavate further and make it, gradually we go down from top to bottom, and this is a method of basically top down method. Advantages of method can be said that whenever we don't have the ground available for a long time, so that whenever we are constructing below a road or a playground, we have got a limited kind of excavation, and these diaphragm walls are acting basically as a structural walls, so that they can take a better loads. And in this method, once we cast the top slab, we can reclaim the top area, and the road or the playground that can be restored back, and we continue to work inside the station. In bottom-up method, where we are having a complete space available for excavation. We excavate the from top. First of all, we install a retaining wall, either in the form of a second pile. So whenever in Pune Metro, we have an excavation depth of average 25 to 30 meter, out of which top 10 meter was soil and descended rock. So we drive the second piles to around 10 meter depth. Second piles are nothing but basically driving the piles and making a retaining wall. In this case, piles are drawn not touching each other, but they are drawn overlapping each other. So that first of all, we insert two adjacent pile in the form of a plain cement concrete piles, which are of a normally lower grade of concrete, say M10. Then overlapping these two piles, we drive a reinforced second pile, which is of a higher grade of M40, and which cut through these piles and make a complete waterproof retaining wall. In this way, once we reach up to the pile driving level, then we start excavation, and by providing, we go layer by layer, and by providing either strut or weathers, we go down further, and when we encounter a hard rock, then the further excavation done only with the help of rotating and rock bolting, and thus the entire depth of the station is achieved, say around 30 meter. Then we start from the base slab and construct the entire RCC structure of the station right up to the top, and then we cover it up. These are the advantages of cut and cover method basically. Top-down method, we can say that settlement can be reduced because these are the structural members which are inserting shorter construction period. Stiffness is higher because floor slabs are already crusted, and it allows us to early restoration because the top portion we can, after putting the slab, we can cover it and continue to work below it. In bottom-up method, there are certain advantages like diversion of obstruction like roadways and utilities possible. It allows contractor to focus on one job at a time, and opportunity to restructure based on the unforeseen impact of site. Waterproofing can be provided in this from outside in this method, that's a more advantage, and drainage system can be properly planned. These are the conditions of cut and cover normally when the top-down method is resorted to. When the top area is highly dense and we cannot take it for a long time, so that I already explained. And bottom-up method is normally done when we have got the entire station length available with us, and we can work for a period of around 4 years to construct the station. Sorry, you can take it.
This is the typical underground station design. This is the transfer section wherein the track level is at the bottom and then followed by the concourse level and then the top slab, which is finally covered with soil so that it becomes the surface which was originally there. This is the bottom-up method. A lot of descriptions and lot of theory is involved. And this is the, we will say, the cut and cover method, that construction sequence, pile boring, then pile concreting, excavation of the first layer, again rock bolting, and putting the anchors in the waller beams, etc. And then excavation of the second end. So sequentially we go down, and then when we reach to the bottommost portion, we start constructing the station. And this is the station, you can, this is the piling and supports. You can see the waller beams, you can see the secant piles which are overlapping each other. And then there is a hard rock which has been covered with shotcreting. And these are the actual photographs. And this is the sequence, underground level, and then construction of base, backfilling, construction of concourse, again backfilling, and all those things. So it sequentially comes up, and this is the platform level. It is backfilled as you proceed up. And the roof slab, again it is covered then, filling and restoration. So This is the way it is constructed, and you can see the various levels here. Swargate station, the bottommost portion is the platform level, and the top portion is the top slab is there, and it will be finally covered afterwards. These are the station excavated, some of the details, and you'll find what was the dimensions. The length is 175 meter, fully done by cut and cover method. And as sir told, that some stations are done with NATM also. So these are the dimensions, huge dimensions of a. This is the data. What excavation we did is approximately 5,88,000 cubic meters, out of which hard rock was 3,76,000 cubic meters. The NATM, it was 39,000 some odd. So huge excavations we did, and then again it was refilled, and the extra material we disposed of properly. This is the station constructions by cut and cover method, actual photograph. You can see the piling and the hard rock there, and the various activities going on. Then when we did the concreting, we have all the data, all the quality control, a very robust quality control done. And all grade concrete, if you see, it was 2,42,000 cubic meters of concrete, right from N15 to M40. And then number of cubes you can see, there are 14,000 cubes with a standard deviation of less than 3.5, which I would say very good considering the various grades of concrete, and at various places, because the work was going on at 5 stations. And then durability testing also, we did the rapid chloride penetration test. The results, if you see, are phenomenal. It's 602 and 972, which falls under a low category, which is supposed to be a very good, excellent. And the water penetration test, the allowable value as per the MORTH is 25 mm. However, we got the values from 1 mm to 9.5 mm for all grades of concrete in all stations. Reinforcement steel also, we used more than 36,000 tons of steel with physical testing and chemical testing done. Huge testing has been done, and we have got the results. We have documented them. They are on record, and we saw that all the steel had passed all the requirements of 1786, the relevant Indian standard. These are the photographs, and huge constructions. You can see places. You can see how deep it was between 25 to 30 feet, 30 meters, like 100 feet deep, and with the buildings, you can see nearby buildings where they're very adjacent to what was going on. And here on the right side, you can see the building. Actually, there was no space. There was a space of 0.6 meter, just we can walk through that. And this is the artist impression and what we constructed. Sambhajinagar underground construction, and these are the construction, a huge construction. When it goes on, it's really a sight to be seen by all the civil engineers to visit it and to know it. Of course, in one visit, it's very difficult to understand the sequence, the stations, etc. However, they can get a feel of it. And as usual, Mahametro is promoting the visits of the students. Very many colleges do visit us for viaduct, tunneling, and underground construction sites. This is the underground station at Civil Court, various phases, various stages. And we will go for use of NATM, which sir already told in brief. However, I will go a little bit more, that it's one of the most popular makers, and it is nothing but the name is new, but it is all we call as a heading and benching method. When I did the tunneling in Pench hydroelectric project way back in 1985, there we used to call it as a heading and benching method. It's the same method, little modified. These are the design philosophies, kinematics, and how we do the failure mechanisms by numerical methods and finite element analysis. And this is the sequence which sir also showed. So I'll skip. And the details of the NATM which we did is, total length of tunnel by NATM was 665 meters out of approximately 5 point something kilometers, so more than about 11%. So this is the cross-section area. Sir also showed this slide. And this is how the layout marking is done on the face before NATM is started. These are the T1, T2 headings, T1, T2, T3, which we saw. This is actual photograph and how we proceed. And these are the average power factor. Now, if you take the top heading 1, the number of holes are between 150 to 155. We had employed a consultant for drilling and blasting who studied the geology as sir told, and then he suggested the drilling and sequence. And these are the little details. And the average powder factor was 0.8 to 0.9. That means in every kg of explosive we used, we got 0.9 or 0.8 cubic meters of excavation. And these are the, for heading 3 and heading 2, for heading 2 there were 70 to 80 holes, and heading 3 70 to 75 holes. Drilling depth was approximately 2.5 meter, and the advance which we used to get is 2 meters, what we will say pull or advance or round what we call is 2 meters, and diameter of drilling holes was 25 to 38 mm as per the strata, as per the whatever details they had, the consultant had. And then horizontally they were 2 meters center to center and 1.5 center to center vertically. And the explosive we used was emulsion explosives with detonators, quantity 0.3 to 0.6 kg per hole. So enough details are there. And then when it was excavated, so after every blasting, every pull, we do the recording, excavation, the rock mass rating, the graphical logging, the geological structural index, everything is noted, and these are the sheets. Huge amount of sheets are available, and the data is digitized now also, but as sir told, we were in a phase wherein we had to keep the records in hard copies also. And that actually helps. This was NATM excavation, the various photographs, and this was the completed section, and before the primary lining and tunneling sequence also sir showed. This is the retrieval and dragging, the primary lining sir told, and what was the primary lining is excavation of rock was this, some details somewhere like in UGC 1, because the contract, there were 2 contracts, UGC 1 and UGC 2. So you will get the idea how much material we used. And then the lining is secondary lining, invert lining, overt lining, waterproofing, reinforcement fixing, shutter fixing, concreting. It's very difficult to tell everything in one session. What I thought is we'll get 40 minutes, but now the time is 20 minutes, so I'm rushing through. But you will get an overall idea, and then if somebody wants it in detail, they can always contact me, Jain sir, or our Honorable Director, Gadgil sir, and you'll get the details. This is the construction joint, how it is jointed, how it is welded at site, and this is the PVC membrane, waterproofing membrane we fix, and then we do the sealing of it, fixing of the waterproofing membrane. And we check also double seam welding, we check for the pressure also. And this is the invert waterproofing and the overt waterproofing. You can see there is a, it is in 3 layers. There is a geosynthetic membrane, then there is a PVC lining of 2 mm, and all these things. This is the final lining, thickness 700, concrete grade M40, slump between this temperature placement, formwork of minimum 24 hours. And these were for the overt lining. So this was the construction joint which I showed you where the waterproofing is required. And this is invert reinforcement fixing. And you can see the photograph, a huge work indeed. And then this is the concreting after it is concreted, thickness 700 mm. This is the shutter. The shutter is a really huge one. It weighs 56 tons. And it is shutter length is 6 meter, but the length is maybe 36 meter. And you can see the shutters actual photograph on site when it is fixed inside, and then there is a traveler, people can work from there, and these are the pockets for the concreting. And the concrete is prepared in the RMC, it is taken to by transit mixer, and then it is lowered down through the concrete chute, a pipe, and then again a transit mixer is there, and there is a concrete pump, and the pump is it is connected to the pump which puts the concrete inside through those pockets. These are the activities, concreting photographs, and you can see, and these are the pockets, and where from where. And there are, you can see the shutter vibrators also. There are approximately, I have written that there are 26 form vibrators, and a well compacted vibrator concrete we can do. This sir has already covered that there was a cavity, and it was actually, it posed a problem and took 2 months to advance. Major engineering challenges were very many, and excavation in the vicinity of heritage structure. Sir also showed these photographs. Damage category also he dealt with, and we did the remedial measure. TBM tunnel in semi-close to close mode. There are 3 modes actually: open, semi-close and close mode. So we did it in semi-close to close mode. NATM tunnel done by control blasting. Proper instrumentation, severe building, category building, after were protected by using propping. You can see the probes also, and suitable instrumentation which sir already dealt. Below the major roads, because when the NATM, when the...
Please conclude in 2 minutes.
Yes, it is in 3 minutes. And when the NATM has to be constructed below the roads, because we have to give the entries to the stations, and by the side of the station there are roads, there are flyovers already, and then we did it with below the road. The crossover tunnel passed through a deep underpass, and the rock cover between the tunnel and the bottom of subway was 9.96 meters. Below major roads, the remedial measures taken where the NATM was done not in 4 parts but 5 parts, 1 to 3 and invert 2 parts, and the allowable ground vibration limit was restricted to 5 mm per second. And to control the peak velocity, line drilling and light charging were done. Round length of 1 meter. Normally we proceed 2 meters, but here the advance was only by 1 meter, and rock bolting, etc. was done. Application of 100 mm thick shotcrete on everything. So this is a flyover near the Swargate station, and we have to cross the road to enter the station. One of the entries, 2 entries are from 2 adjacent roads which are perpendicular to each other. So we have to cross by having a NATM. So this is actually the flyover existing, and our NATM was just below the piles which were there. So the distance between toe of pile and from tunnel periphery was only 4.6 meters. So it was really a challenge, and we did it by having control blasting and taking light blast, advancing 1 meter. And TBM tunnel which sir dealt was also below he showed the Google map wherein you could see that the tunnel passed through the river also, so below the Mutha river, and we did the geotechnical investigation on this floating ramp, and then river width was 100 meters. Twin TBM tunnel was driven in modestly weathered to fresh rock. To control the water ingress, TBM was set to proceed in closed mode with the earth pressure balance applied at the tunnel was 150 kilopascals. So this was all, because we can go on speaking on this topic for hours, but because of the shortage time, and I thank the organizers and the chairman and co-chairman to kindly bear with me. Thank you all.
Thank you so much for the nice presentation.
Thank you.
Over to organizers.
If anybody has questions, they can always discuss with 3 of us. Our director is also there in the lunch time.
Thank you, Taide sir, and thank you, Jain sir. Now I request session chair to please felicitate. Thank you, sir. Now I request Dr. Karwane sir and Dr. Dikshit sir to please felicitate chairs. Thank you, sir. Now there will be lunch break. At 2:30 p.m., there will be Bright Spark lecture, and after that, validity function will be there at 3 p.m. Hello, welcome back. Now we will have Bright Spark lecture. Please join me in welcoming to the stage Professor KGN Shao, Vice President Asia, Dr. Anil Joseph, President IGS, Dr. AP Singh, Secretary IGS. I also welcome Dr. Akanksha Tyagi to the stage. I request AP Singh sir for the background of Bright Spark lecture.
Good evening to all the honorable fraternity members. I welcome you all for the Bright Spark Lecture Award. And I will tell about the background of the Bright Spark Lecture to promote young members of ISSMG to play a major role in various international and regional conferences. The Bright Spark Lecture Award was introduced by past president of ISSMG, Professor Charles NG. The award was created for promising young geotechnical engineers in both industry and academia to have a chance to deliver keynote and invited lectures at national and international conferences. So with this background, this Bright Spark Lecture Award was initiated. Last year, we had 3 Bright Spark Lecture awardees, and this year we were having only 2. And one of the awardee is Dr. Akanksha Tyagi, a professor in IIT Roorkee. So I will ask to introduce Akanksha Tyagi to Alka. Yeah, come.
Thank you, sir. Before starting the lecture, I would like to give brief introduction about Dr. Akanksha Tyagi. She is an assistant professor at the Department of Civil Engineering, Indian Institute of Technology, IIT Roorkee, since July 2019. She obtained BTech in Civil Engineering from GB Pant University of Agriculture and Technology in year 2011 and was awarded the Vice Chancellor Gold Medal in BTech Civil Engineering. She has done MTech in Geotechnical Specialization from IIT Bombay in the year of 2011 to 13. She earned her PhD from the National University of Singapore in 2018 and received the NUS Research Scholarship from prestigious National Research Foundation Singapore and Ministry of Education Singapore. At IIT Roorkee, her research area include tunneling and excavation in soft soil, in situ ground improvement techniques, cut-off wall seepage barriers, modeling spatial variability, random finite element analysis, and use of industrial waste as geomaterials. She is also associated faculty member at International Center of Excellence for Dam at IIT Roorkee. She is awarded SERB Core Research Grant for project titled Reliability-Based Design of Tunnels in Anisotropic Spatially Residual Soil Slope for the period of February 2023 to 26. She is a co-PI for project title Development of Guidelines for Instrumentation and Real-Time Monitoring of Hill Slope, worth 4.33 crores funded by Ministry of Road Transportation and Highways, Government of India, New Delhi, for duration 2024 to 29. She is recipient of IEI Young Engineers Award 2024 in Civil Engineering discipline from the Institution of Engineers, India. Dr. Tyagi is associate member of American Society of Civil Engineers. She is also a life member of Indian Geotechnical Society and nominated member of TC 307, Sustainability in Geotechnical Engineering, International Society for Soil Mechanics and Geotechnical Engineering for the term 2022 to 25. She is also associate member of the Institution of Engineers, India. She has guided 5 MTech theses till the date and currently supervising 10 PhD and 2 MTech students. Dr. Tyagi research work are published in reputed peer-reviewed journals that include ASCE, Journal of Geotechnical and Geoenvironmental Engineering, elsewhere Tunneling and Underground Space Technology, elsewhere Construction and Building Material, ASCE Journal of Hazardous, Toxic and Radioactive Waste, and ASCE International Journal of Geomechanics. Now I request Joseph sir to please felicitate Dr. Akanksha ma'am. Thank you, sir. Now I request Dr. Akanksha ma'am to please start the lecture.
A very good afternoon to everyone. It's quite an overwhelming feeling. Firstly, I would like to thank ISSMGE and IGS for bestowing on me this prestigious Bright Spark Lecture Award 2024. Thank you. Thank you very much. Today I'll be speaking about the topic which is close to my heart, and I've been working on it since my PhD with group. I'll be mostly discussing about design framework for circular tunnels with cement admixed soil surrounds. And I'll be also touching upon modeling spatial variability of cement admixed columns using random finite element analysis. So, this is a Purnam tunnel in soft lateritic soil, Goa, and this was constructed in 90s. And this is what is written in Wikipedia. The chief engineer of the tunnel construction defined it as a job from hell, with repeated floods caused by monsoon weather that could wash away months of work in a matter of hours. 9 workers died during the Purnam tunnel construction alone out of total 74 deaths during the Konkan railway project. In another report, which is the impact evaluation report of Konkan railway project, it's written that the scheduled rate, it was 3 years after its original scheduled time, and it actually costed them 3,350 crores at that time with a 222% cost overrun. And what was the reason? Reason was soft laterite soil, and they had to literally dig the tunnel through the soils. Now, at that time, there were no TBMs, and the technology was not that advanced. You can ask me now with the new technology, we have lesser problems. Yes, we are constructing tunnels at a faster pace, but still there are challenges. So this is a picture. This is a snapshot from a newspaper article 2015, where a heritage building suffered cracks due to Delhi Metro tunnel work. Another infamous incident is the Bao Bazar incident, in which TBM got stuck and the heritage houses developed cracks. The problem was high hydraulic gradient, and the soil strata comprised of silty sands, sandy silts, clayey sands, where when the fines are too much, then the conventional grouts or conventional grouting techniques like permeation grouting or injection grouting, they won't work. Then this is a recent article I just searched, and I got that school building, it suffered cracks due to Chennai Metro project. So although we are having successful projects, but still it's really challenging and it's highly risk prone. even after the construction of tunnels, it's not that our job is over. The picture on the left that you see here is again the same Parnam tunnel. You know, it suffered again the wall failure in August 2020 due to heavy rainfall. And it's not that these things are happening in India or developing countries. No, it's not like that. There are several failures that are occurring due to triggering factors like rainfall, or the right picture that you see is the station collapsed in Japan due to earthquake. So this is the main motivation behind my research, the various challenges that we face that when we construct tunnels, and what are the triggering factors which can again cause trouble for our tunnels. So the first topic that I am working on is tunnels in soft clays, which are improved by deep mixing techniques such as jet grouting or deep cement mixing. This picture is for TBM breakout in Malaysia, and you can see that the TBM is breaking out in limestone formation, but above it you can see these are some columns. Now these columns are not piles. They are actually deep soil mixed columns. These are soil cement columns. They look like contiguous piles, but they are not. The second picture here is from the Bedok MRT station, Singapore. And again, this is a deep soil mixed column where cement slurry is mixed with the help of auger and cutting tools, and you can get columns up to 40 meters of depth. It's a greener technology because we are not using concrete, we are actually mixing cement with the in situ soil. So we are making stiffer columns as compared to piles. And cost-wise also, it is cheaper. The mobilization cost, of course, will be higher if we are using this technology for the first time, but once we have this technology available in our country, then the cost becomes cheaper than the conventional piles. The second topic that my research group is working on is the tunnel in residual soil slopes. The picture that you see, it's a very interesting picture taken by my PhD student, Sushant, who went for a LARAM course to Italy this year. So this is showing you the two tunnels, you know, at different cover depths. And because of the slopes, the tunnels, they suffer from asymmetric loading. And if the tunnel is shallow, then the problem becomes even more dangerous. If I talk about in Indian context, then in Konkan region, we have lateritic soils where, you know, new tunnels have been, will be constructed, and they are being constructed. And again, the lateritic soils are very, very difficult, especially in the monsoon season where they flow like a slurry and they become like a, you know, soft rock in summer. So in fact, if you see the old reports, the project engineers used to define those lateritic soil as a chameleon, which changes its behavior. So the third topic I'm working on, my research group is working on, is tunnel in sands and silts under seismic loading. When my student started working on this topic, then, you know, different questions come, and very interesting question come that where do this kind of scenario will occur, like you have a shallow tunnel and you have sand. So this picture I have taken, and fortunately I got this opportunity to take this picture myself during my Chennai visit this year, during the women's conference. This tunnel is at the beach, and it's beach sand, and as you can see, the tunnel is quite shallow. The least cover is only 3 meters, and they told me that the cover depth is increasing from 3 meters to 15 meters. So it's very, very shallow tunnel. And we are working on basically interlayered strata. So the strata that we are seeing in the bottom, at the right bottom picture is from the Kolkata. And the Kolkata has silts, sands, it is all interlayered, and so we are studying this problem as well. So if I talk about my first problem, which is the tunnel in soft clays, we started working on this during my PhD, and the topic was design framework for circular tunnels with cement admixed soil surrounds. I worked on single tunnel, which is surrounded by an improved soil surround, and I conducted centrifuge model tests. The picture here shows cracks encircled. So this circle that you are seeing here is not lining. It's actually the improved soil surround, because usually in centrifuge, we are having a small scale test, which is generally scaled up when we are using a centrifuge at some n gravities. So primarily we use centrifuge to see what are the failure mechanisms. After studying the failure mechanisms on single tunnel, and also I studied the influence of second tunnel, a new tunnel which is being collapsed due to some reason on the existing tunnel. I also conducted numerical modeling, because the basic question is, in the field, your ground improvement will never be this circular and this homogeneous. So we have to take care of the columns that we actually construct in the field. So in the numerical modeling, we can do that. We actually simulated those columns. We simulated spatial variability in those columns, and we also simulated the positioning errors, because we are humans. When I say that you have to make overlapping columns, it's not that we'll be making columns at equally spaced, and vertical columns, they'll be tilted, they'll not be equally spaced. So we also model that. Now, after coming to IIT Roorkee, I extended this topic and gave this one to my third MTech student, and he worked on rectangular tunnels in improved soil surrounds. So, second topic, tunnels in residual soil slopes. We are working on a project reliability-based design of tunnels in especially variable soil slopes. And as I told you, my primary interest is the Konkan region. And when we went there and we saw the slopes, so many cutting failures happen every monsoon season. We are basically working on the reliability-based design. We are considering the spatial variability in the lateritic soils and how it will govern the stability of tunnels. Two of my research scholars are working on it, because we found that this problem is actually multifaceted. It's not a single problem. There are several problems associated with the slopes, and then if you have a tunnel there, more problems, more issues come. Third problem is, as you can see, it's an interlayered soil deposit, and we have a tunnel, and we are studying the effect of input motions, earthquake motions, and we are seeing what is the effect, how the lining is responding. We are using some of the advanced models like PM4 sand and PM4 silt, and we are applying to study what are the bending moments in the tunnels, and also what is the deformation. So we are trying to quantify that deformation. We usually know that, okay, ovalization happens, raking in the tunnel happens, but how to quantify that deformation? Because that is important for the engineers, so we are working on it. So this was the overview of what we are doing. Now, I'll be speaking more about the first topic, as I said, in the rest of my time. So, when the soil is very soft, we have to do some kind of ground improvement. So one type of ground improvement is the in situ soil mixing. The first picture is from US, and here you can see that the jet grouting has been done prior to the tunneling, and you can see that this extent of jet grouting has been done so that it is giving some kind of circular improvement prior to the tunnel construction. So you can see here that the problem I was working on during my PhD is actually something like this, a circular kind of construction. Now, the thing is, there are several literature available for tunnel in soft soils. We have established design charts, we have stability equations, we know how the tunnel is collapsing, shear failures occurring, what is the face stability, but do we have any idea about how much I should improve, what should be the extent of this improvement? So, this picture is actually from Land Transport Authority, Singapore. It is from Thomson Line. And you can see that the extent of improvement, it's 25 meters of cement treatment, and actually the soft clay has been changed to soft rocks. And you can see the width, along the width also, it's quite, the improvement is huge along the depth. Can we do these things in developing countries? Of course not. Why did it happen in Singapore? Because of, there are no codal provisions, there are no guidelines. So to be safe, to be on the safer side, if you have money, okay, just do. the whole ground improvement. So this was the main motivation. Now, how to develop a design framework for engineers? So we came out with the centrifuge model tests to understand first how the failure will happen, what will be the failure mechanism. Then we conducted finite element modeling because centrifuge model tests are expensive, time-taking, so you cannot do all the parametric studies in centrifuge. So we did finite element modeling for preparing some basic charts and giving modified stability equations. And then we tried with the advanced modeling technique, random finite element method, so that we can actually simulate columns and can see what is this effect of positioning error, spatial variability, and how geotechnical engineers can take this into account. So this is the centrifuge model. This is in Singapore. And you can see that this is that circle thing. Actually, it's a clay, which we generally put between the boundary of the tunnel and the perspex glass. So it's an instrumented setup. This picture is interesting because you can see 3 distinct failure patterns in the improved soil surround. Usually in soft clays, we have shear failure. We don't have tension failure. But actually in this, when you improve the ground, then the tension failure, the tension cracks will occur. So when the tension failure will occur, when the strength is higher and also the thickness is also higher. Now usually when we go for ground improvement like jet grouting and deep soil mixing, if I say 1 MPa design strength, it's not uncommon. Usually if you're adding cement, the strength will increase with time. So if the design strength is 500 kPa only, the contractor will add so much cement that the minimum strength has to be 500 kPa. Definitely the strength of that ground is more than 1 MPa or so. So in numerical modeling, finite element, we cannot model cracks, but we can see how if there are some negative stresses, negative minor principal stresses, so we can see if the crack can initiate or not. That initiation we can actually predict. So I validated with the numerical model, and finally, what's useful is the chart, failure chart, where the y-axis shows the strength ratio, improved soil surround by the surrounding soil, and the x-axis is here the thickness to diameter. So actually, you can here from this chart, if I can play with the extent of the improved soil surround and the strength of the improved soil surround, I can actually know what type of failure we can expect. Now, stability equation was also important. We have classical Brom's and Benemark stability equation. So we proposed a modified stability equation. The numerator, you will see it's the same. The denominator is different. The denominator here is now taking care of the strength of the improved soil surround and the thickness of the improved soil surround. And it is also taking care how much mobilization of strength will occur in the surrounding clay. Because once you improve, the whole mobilization of strength will not occur in the surrounding soil. Now going ahead with the random finite element analysis, basically it's a tool. We all know what is finite element analysis. We are using softwares like Plaxis and Abacus. Now, random finite element analysis combines the finite element and random field methodologies. Usually, in the field, if we are improving the soil, then the strength is not a single number. It will never be. So, as you can see here in this 3D random finite element analysis, here you can see that this darker zone, actually you can see the columnar construction. The darker zones are specifying the higher strength, while the weaker zones are specifying the lower strength. And we modeled the overlapping columns which are not equally spaced. There may be some positioning error. We modeled the coefficient of variation. We also modeled the autocorrelation distance, which are all the parameters related with the stochastic or random finite element analysis. Again, this is of academic interest, how it is useful to geotechnical engineers. So we had to come out with a number, with a factor that, okay, how should I take this special variability in my design? So we came out with the strength reduction factor alpha. So if from this chart, I've been told what is the coefficient of variation we are expecting in the ground. if it is 40%, or what is the positioning error that we are expecting in the ground, then for different confidence intervals, we can actually find out what is the strength reduction factor alpha. And from the strength reduction factor alpha, I can find what is the design strength. Now this design strength, engineer can use in their conventional finite element, and they can actually factor down the mean strength and use this design strength for their actual problem. So finally, I come out with the summary. There is some error in the format. So we did first physical modeling, okay, centrifuge modeling. Fortunately, we had a centrifuge to see what are the failure mechanisms. Then from the centrifuge results, we actually came out with the numerical model, and that helped us to come out with the design charts and the modified stability equation, but that was not enough because we have to see what is actually happening in the field. So we took the field data and we took the random analysis and finally came out with the design framework for geotechnical engineers. If any student is interested, then these are the number of publications from the work, and these are the references. Hopefully I have completed this on time. Thank you so much.
Thank you, ma'am, for the valuable insight about the topic. Now I request Professor Albert Shaw, Vice President Asia ISS MGE, to present Bright Spark Lecture Award to Dr. Akanksha, ma'am.
On behalf of ISSMG, I would like to deliver this certificate to the recipient. This certificate was signed by our President, Mark Ballons. Thank you.
Thank you, sir. Thank you, ma'am. Now I request Dr. A.P. Singh, sir, Secretary IGS, for the IGS Award.
Good evening once again. Now we will go with the award function, which is to be given in the valedictory session. So we are officially starting the valedictory session. First of all, we will give a award for reviewers award for our journal, Indian Geotechnical Journal. So I will request Professor Dipankar Chaudhary and Sonal Chaudhary to please come on the stage so that we can start. I will request Professor Deepankar Chaudhary to give the background and some few words about the Springer Award. Please.
Good afternoon, all. Thanks, Dr. A.P. Singh. So I will just update about the Indian Geotechnical Journal, the recent progress of the journal. And I first thank the entire team of editorial board, associate editor, and our IGS headquarter, also the Springer, with whom we are publishing this journal. And can I have the slides change, please? There is no slide changing. So this is what our present status of the journal. This journal started in 1971. Currently, we are actually completed 54 years, so 54 volume has been published. Currently, it is ESCI Scopus indexed, and also impact factor it has received last year, 1.4, and 5-year impact factor is 1.5. All the members of IGS can download it free, view for all members, and bookmark and subscribe to notification. That is a request to all of you. You can put your email in the website, then automatically whenever new issue comes, you will get a notification that the new issue has been published. A quick information about the impact factor of last year, which the Clarivate Web of Science has published, that 1.4 and 5-year impact of 1.5. This journal received first impact factor last year, that is 2022. It was 1.4, so we continued with that. This is our citations over the years. It is increasing, which actually helps in our impact factor in long run. Also, how our society journal stands with respect to other international society journal of repute in our area in geotechnical engineering. A comparative statement I have given as an editorial comment in this issue. You can get the details. So 22 to 23, there is most of the journal decrease their impact factor because of the Clarivate and Web of Science policy, but we could maintain the same impact factor, you can see, which is a good sign for our journal, but we have of course, further to improve on this. And for that, we need help from all of you. All of you means it includes the author, reviewer, reader, and everyone. So this is our relationship of citations of the journal, how international other journals cite our papers. This pie chart actually shows, and it also, we want to get it improved. This is the data which Springer shares. So thanks to Ms. Sonal, who is a publishing editor from Springer, who handles actually this Indian Geotechnical Journal. Over the years, our number of submissions are increasing tremendously. You can see the growth. Also, the number of publications automatically increases. The acceptance rate also hovering around 25%. Last year, it was little more because we had 2 special issues last year, so special issue always get more acceptance or more attention. Rejection rate, that's why also hovering around 60%. Last year it decreased a bit. Number of downloads is one of the major factor for any journal. If it is high, then it gets more royalty, it gets more impact factor, it gets more visibility and everything, all the data metrics. So you can see there is a significant, tremendous growth for our journal. So thanks to all of you. Last year it reached, actually it crossed first time the 1 lakh mark. It is now 1.21 lakh of downloads. This data is still November, so still this month also it will get added, which is very good sign of the progress for the journal, as I understand from the Springer. This is the author diversity. Mostly, of course, it caters for the India and surrounding region. The majority of the submission comes. The next highest one comes from the China, and the third highest comes from the Middle East, which essentially Iran, Iraq, UAE, etc. This is the one important factor which actually very much influence on the journal growth. That is the turnaround time. Many of you, those who are authors, always wondering what is the turnaround time. That is submission to first decision. We always want to reduce. If it is reducing, then only our journal can grow faster and impact factor, everything will improve. So we are trying to reduce this number. You can see over the years we are doing that. Also, If you see the submission to acceptance, that also we want to reduce, which is happening. And here also I need help for all the reviewers and the editorial board over there. Coming to a good part of the journal, journal actually earns our royalty for our society, Indian Geotechnical Society. Last year, it earned 13.62 lakh. Previous year it was 10.64 lakh. We actually have an increase more than 30% for this earning in the royalty of the IGS for this journal. So this is a really good sign, and that is where more number of downloads, more number of publication, less turnaround time, these things actually help for the journal, which is good for our society, Indian Geotechnical Society. I'm very happy to show this slide, but this will be officially announced soon. Every year we give the award to the best reviewers, and since last year we have increased the number of awards from 3 to 9 under 3 different categories. Thanks to Springer for agreeing to that, and also our IGS headquarters. Through various rigorous selection based on the data, that is how much turnaround time, how much efficient review, detailed review, everything has been taken care of. How many more number of papers they have handled. Based on that, these 3 categories, each of the awards will be giving. And each of these first prize, second prize, and third prize are 300 euro, 200 euro, and 100 euro book voucher, which Springer will be giving along with our IGS certificates and Springer memento. So with this, I close this presentation, and thanks to all of you. Please contribute to this journal of our country for your journal, your growth, and everything. Thank you so much. Namaskar.
Thank you very much, sir. Now I take the privilege to invite the guest of honor, Shri Arun Agrawal, Director, Kalika Steels, to grace the dais. Similarly, I invite the chief guest, Joint Managing Director, MSIDC, Engineer Mr. Vikas Ramgude, and Professor Munish Sharma, Director General, MIT, to kindly grace the dais. Dr. Uttam Karvane, Chairman, IGS Conference, also to grace the dais for the valedictory program. So we are here for the valedictory program. I'm sure you all have enjoyed this conference in all ways. The educational content, the research content, you must have gone around the city, you must have enjoyed the food, and you must have enjoyed a lot of interaction with the fraternity of your area I'm in. So I really feel great to have you all for this valedictory program. At the outset, I request the Director General, MIT, Professor Munish Sharma sir, to share his views on this occasion of valedictory program. Thank you.
Good afternoon, friends. And we have excellent dais today. Chief guest, Mr. Vikas Ramgude, and President of IGS, Dr. Anil Joseph, and all other distinguished guests on the dais and off the dais, and all the participants. I think we have all the reasons to smile and feel happy about what we have witnessed in last 3 days. Let us clap for the great success of this annual convention of IGS 2024. And I think there are many things which we can really talk about it. And it started with the annual lecture, and I think the praise we have received from the entire globe, people who was watching the whole proceedings. It was great telecast. In fact, I was continuously watching this from my mobile phone, and the whole telecast of the program, I think the team sitting here, they made this convention very, very special because of the use of technology and the great convenience to anyone who would like to learn and to know that what is happening in this space. So I think this team also deserves a lot of big applause. And Sneha Joshi is sitting there, is instrumental and driving the team day and night. Can we clap for Sneha Joshi? She's there. And I was talking to about that the annual guest lecture which we had, and in fact I attended that almost 2 hours session, and professors made that lecture so interesting. Let me tell you that even if you are not from that technical background, still you really would understand that what he is talking about. And I really appreciate this great art to make so complex research interesting as if you are telling a story. And thank you for making that, the very first opening lectures set the tone, and I think that spirit's carried forward throughout 3 days. And all the breakout sessions, the theme speakers, and all the interaction which happened, it was really great to witness. And therefore, we must congratulate the President, Honorary Secretary of IGS, the entire team, and of course, the IGS local Aurangabad chapter, Organizing Secretary, Dr. Manish Uttam Kalwane, Chairman of the chapter, and the whole MIT Civil Engineering Department, to make this program so knowledgeable and interesting for each one of us. I think we should keep clapping, actually. And I could also witness something very important, which is very, very important for any profession. A nice blend of industry participations, working professionals, and of course, academicians and researchers. So you might have seen excellent presentations from the industry partners, and of course, the exhibitions, all the stalls. All the stalls were very well equipped and manned by very knowledgeable people. I personally had interaction in few of the stalls, and they were actually giving a lot of interest in whatever we're asking for. So big round of applause to all the. I thought I'm not doing your duty. This is you supposed to do it, but I'm just helping you. So it's excellent blend. We could see that what I'm saying, the working professional and academician researchers and the working and the industry. So this is again something very great. It was coming to my mind as if this is a science congress of geotech. That kind of the feeling was there, so I thought I should mention the same. And what I can say that MIT Civil Engineering Department is capable enough to take care of IGS chapter, local chapter. But of course, after seeing the importance of the geotechnical as a subject and as a domain, I think this is something which in times to come, MIT Civil Engineering Department would really give more emphasis in terms of resources, in terms of building right kind of laboratories, and of course, the right kind of people who can actually spend quality time in both in terms of collaboration and research. So, of course, we'll see that how we can build this chapter more stronger in times to come. And I can assure IGS society that you can always count on us wherever you really find to drive any activities of IGS of any scale. We will be there to support you. And I'm also happy that the entire proceeding is getting published, and one of the renowned science publication in the world, Springer, is helping us in terms of coming up with all the papers are in 10 volumes are getting published, I suppose. 10 volumes are getting published, and this is something very, very great thing which is happening as one of the outcome of this conference. So we are going to miss all of you, and you are great participants. You really made the campus very vibrant with your presence and all the discussion, debates, and so a lot of interesting, even informal talks, whatever happened, have really remained there in the air of MIT, and we'll keep enjoying that, and wish you all the best, and hope you have a safe journey back to your home. Thank you very much.
Thank you very much, sir, for the energizing words of appreciation. I'm sure with these words, everyone is energized and has got the surety that the takeaway of this conference is going to be great. And MIT is there for every to grab every opportunity to be at the service of IGS. So thank you very much, sir. Now I request the Director General, Professor Munish Sharma, sir, to felicitate the guest of honor, Mr. Arun Agrawal, Director, Kalika Steels. Thank you very much, sir. Now I request Professor Munish Sharma, Director General MIT, to felicitate the chief guest of today's function, Joint Managing Director, MSIDC, Engineer Mr. Vikas Ramgude. Thank you very much, sir. Now I request Dr. A.P. Singh, Secretary IGS, his views. Thank you very much.
Good evening once again. Now we will go with the award function. First, I will take up the Springer Reviewers Award. The Best Reviewer of the Year 2023. These are the awards to be given today. Journal Review Award, 9 numbers. Best Paper Awards, 11 numbers. Young Geotech Engineers Award, 8 numbers. IGS Appreciation Award, 6. Geo Vishleshna, 2024 Competition Award, 3 numbers. So first I will go with the Indian Geotechnical Journal Award. Best Reviewer of the Year 2023, Non-AVM category award. First prize goes to Dr. Venkatraman Balakumar. This award, Dr. Balakumar has been awarded the first prize of Best Reviewer of the Year 2023 Non-EVM Award in recognition of his outstanding contribution to the Indian Geotechnical Journal. The second award in this category goes to Dr. Ramu Badiga. This award has been awarded the second prize of Best Reviewer of the Year 2023 Non-EVM Award in recognition of his outstanding contribution to the Indian Geotechnical Journal. The third prize goes to Dr. Meenu Trisha Abraham, awarded the third prize of the Best Reviewer of the Year 2023 Non-AVM Group in recognition of her outstanding contribution to the Indian Geotechnical Journal. Now the next category is Best Reviewer of the Year 2023 EBM. First prize goes to Dr. Sarvesh Chandra, awarded the first prize of Best Reviewer of the Year 2023 award in recognition of his outstanding contribution to the Indian Geotechnical Journal. Second prize goes to Dr. Tanusri Chakravarti, awarded the second prize of Best Reviewer of the Year 2023 in recognition of her contribution to the Indian Geotechnical Journal. Now the third prize goes to Dr. Sarat Kumar Das, SK Das, awarded the third prize of Best Reviewer of the Year 2023 EBM Award in recognition of his outstanding contribution to the Indian Geotechnical Journal. Next category is the Best EBM of the Year 2023. The first prize goes to Dr. Kumar and Pichumani. Is there? No one to take? Second prize goes to Professor N.K. Samadhiya, sir, awarded the second prize of Best EVM of the Year 2023 in recognition of his outstanding contribution to the Indian Geotechnical Journal. Third prize goes to Professor Krishna R. Reddy, awarded in recognition of his outstanding contribution to the Indian Geotechnical Journal. No one is there. Now with this, we end the journal award to the contributing reviewers from EVM and non-EVM group. Now I will announce the 11 best paper awards. When an award-winning paper is authored by more than one author, one of the authors may please come forward to receive the award on behalf of all the authors. I request Dr. Anil Joseph, President IGS, to do the honor. First IGS ML Biennial Award for the best paper published in the Indian Geotechnical Journal has been awarded to the paper The Horizontal Mode Natural Frequency of a Floating Pile in Layered Soil, Full-Scale Field Test versus Mathematical Model by Raman Burgess, S.R. Varun Nagesh, Subhadeep Banerjee and A. Bhuminathan. I request the author to come and receive the award. Anyone from IIT Madras, IIT Chennai? No. IGS ML Biennial Award for the best paper on instrumentation has been awarded to the paper Convergence Confinement Method for Squeezing Prediction in Rohtang Tunnel, a case history by Aswani Jain and Professor K.S. Rao. IGS FCON's biannual award for the best paper on case histories has been awarded to the paper 3D monitoring in tunnels, ground support interaction and its implications with emphasis on tunnel T74R of US BRL Project India by Ayaz Ahmed, Sudipta Kumar Mishra and Pratap Chandang. Moment. Okay. IGS Srimati Indira Joshi Biennial Award for the best paper published in Indian Geotechnical Conference in the area of environmental geotechnology has been awarded to the paper Sealing and Volume Change Behavior of Gallen Gum Amended Granular Bentonite under Extreme Chemical Loading for Landfill Applications by Himanshu Yadav and T.V. Bharat. IGS Geotech Biannual Award for the best paper on innovation in field exploration has been awarded to the paper Dilatometer, an in situ soil exploration tool for problematic ground condition vis-a-vis for economizing construction activity by Kausik Bandopadhyay, Kaustav Das, Saptarshi Nandi and Abhipriya Haldar. IGS Professor C.S. Desai Biennial Award for the best paper on constitutive modeling for geologic material has been awarded to the paper Calibrating of Rheological Parameters and Modeling the Runout Process of Debris Flow by Meenu, Trisha Abraham and Nilima Satyam. IGS Sri A.G. Dastigar Biennial Award for the best paper on ground improvement has been awarded to the paper Bearing Capacity and Liquefaction Assessment of Shallow Foundation resting on vibro stone column densified soil in Vallur Oil Terminal, India by Tanmay Das, Meghna Sharma and Deepankar Chaudhary. IGS Geotech Biennial Award for the best paper on geosynthetics and allied construction products has been awarded to the paper Behavior of Luge Geogrid Skirted Square Footing Resting on Reinforced Sand Subjected to Eccentric and Inclined Loading by B. Kirti Mai and Narendra Kumar Samadhiya sir. IGS Warangal Chapter Biennial Award for the best paper on solutions to the problems of expensive soil has been awarded to the paper Investigating Effect of Soluble Sodium Sulfate Contamination on Swelling Behavior of Untreated and Lime-Treated Soil by Sivansi, Arvind Kumar Jha and Mohammad Parvez Akhtar. Next award is IGS Chennai Chapter Biennial Award for the best paper on deep foundation retaining structures. It has been awarded to the paper Numerical Modeling of a Rock-Socketed Pile under Compressive Loading by Meenu and George and V.V. Majhi. Subhadeep, he has not come. He has not come. So, last award of this category, IGS PJ Rao YR Full Biennial Award for the best paper on geotechnical professional practice has been awarded to the paper Ground Characterization and TVM Performance Evaluation in Fractured Basaltic Terrain near the Arabian Sea, India by Ansul Sidwani, VMSR Murthy and Muhammad Rafiq. With this IGS award is completed, now I will go to the another category of the award, which is the Young Geotechnical Engineers Award. So IGS has instituted Young Geotechnical Engineers Award, Biennial Best Paper Award to motivate and encourage young geotechnical engineers to participate in geotechnical research and fieldwork. Now I will announce 1 year Young Geotechnical Engineer Best Award, Best Paper Award for 2024. This award carries a memento and certificate. I request Dr. Anil Joseph and chief guest of today, please come and give the award. IGS Kochi Chapter YG Award for the best paper on deep foundation has been awarded to the paper Analytical Evaluation of Settlement and Interaction of Floating Granular Pile Raft Units in Group by Ashish Solanki. IGS Ferreco YG Award for the best paper on dam engineering and allied areas has been awarded to the paper Design and Development of Tilt Table-Based In-Flight Simulator for Pseudo-Static Loading in Geotechnical Centrifuge by Pankaj Kumar. Sir, please. IGS Ahmedabad Chapter YG Award for the best paper published during immediate past Indian YGE conference has been awarded to the paper AE Event Count Based Damage Evolution and its application in Micromechanical Damage Plasticity Model by Subham Chajit. IGS Baroda Chapter YG Award for the best paper on ground improvement has been awarded to the paper bearing capacity of annulus stone column double encapsulated with geotextile by Muhammad Sakil Abid. IGS Delhi Chapter YG Award for the best paper on computational geomechanics has been awarded to the paper Vibration Mitigation using dual open and infill trenches in layered soil media, field test and numerical solutions, simulations by Nitish Johri. Nitish Johri? Okay. IGS Dr. M.D. Desai Memorial YG Award for the best paper on geosynthetic and natural fiber has been awarded to the paper Role of Particle Shape on the Shear Strength of Sand GCL Interface under Dry and Wet Condition by Anjali G. Pillai. IGS Guwahati Chapter YG Award for the best paper on soil dynamics and earthquake engineering has been awarded to the paper Protection of Pipeline Below Pavement Subjected to Traffic-Induced Dynamic Response by Chaidul Haq Chaudhary. IGS HICO YG Award for the best paper on slope stability and landslide has been awarded to the paper probabilistic physical modeling and prediction of regional seismic landslide hazard in Uttarakhand state, India, by Kunal Gupta. Now I will come to the appreciation award. There are 6 appreciation awards. First award, IGS Roorkee chapter organized a successful IGC 2023. In recognition, IGS Roorkee chapter is presented with a memento and a certificate. I request all the Roorkee chapters team to come on the stage and take the award. Next is
I think I should also be given best PhD examiner because I have got, right now, I have seen there are 5 papers for their PhD, I was the examiner.
Thank you, sir. IGS Chennai chapter organized a successful WIGC Women Indian Geotechnical Conference 2024. In recognition, IGS Chennai chapter is presented with a memento and a certificate. I request Dibya and team, I all come and फिर ले लेंगे. फुल ले जाने दिए, फिर ले लेंगे. IGS Hyderabad chapter hosted 9th Ferroco Terjagi Oration 2024. In recognition, IGS Hyderabad chapter is presented with a memento and certificate. I request the chair and secretary of the IGS Hyderabad chapter to please come forward and receive the award. IGS Surathkal chapter and IGS Bangalore chapter hosted 3rd Indian Symposium of Offshore Geotechnic ISOG 2024. In recognition, IGS Surathkal chapter and IGS Bangalore chapter is presented with a memento and a certificate of appreciation. IGS Kochi chapter organized excellent technical activities for the benefit of professional credibility. In recognition, IGS Kochi chapter is presented with a memento and a certificate. I request all the Kochi chapter members to come and take the award. IGS Trichy chapter organized technical activity under ISSMG Technical Committee. In recognition, IGS Trichy chapter is presented with a memento and a certificate. I request the IGS Trichy chapter member to come and take the award. Now we will come with the Geo Vishleshna Award 2024. This is a competition conducted by IGS SC7 student chapter activities and continuing education. The award carries a cash prize of rupees 10,000 and a certificate. The first position is awarded to Mr. Dev Yadav and Sneha Rao Saheb Pajal. I request Dev and Sneha to come forward and receive the award. No. Geo Vishleshna 2024 competition conducted by IGS SC7 chapter activities and continuing education. The award carries a cash prize of 7,500 rupees and a certificate as a second position award. This award is awarded to Mr. Mehta Deep Suryakant and Ms. Chaudhary Priya. Second award. And Mr. Piyush Deepak Shane and Mr. Nishant Santosh Karat. No, one more. Geo Vishleshna 2024 third prize is awarded to Ms. Begum Tabani Jia and Mr. Subham Kumar. I request Begum Tabani Jia and Subham Kumar to come and take the award. Thank you, dignitaries. Ladies and gentlemen, thank you very much for your appreciating, clapping for the winners of the award. Thank you very much.
Thank you very much, sir. Congratulations to all the award winners and best wishes to the participants. Getting the Springer or IGS awards is indeed a prestigious achievement. It inspires Dr. Anil Joseph, President IGS, to share his views.
Good afternoon, all. Indeed, it was a get-together of a big family of the foundation engineers. So we came here on 17th. Here, 18th, we had the Indo-Japan, 4th Indo-Japan workshop on high-speed rail. Then the last 2 days and today, lot of activities and knowledge sharing has happened. I always say this is the annual celebration of the Foundation Engineers get together, right from Arunachal to Gujarat and from Kashmir to Kanyakumari. The people are all here. I know it has been a long days ahead to hear, but the most important aspect is that rather than publication paper, listening to that, you get the opportunity to network with many number of people of your age, your group, so that you can understand what is the research happening and what is the activity happen. And always, as I used to say, please remember that engineering is the art of applying knowledge into practice. So don't get the knowledge into you, try to apply it in the field, and make sure that we are contributing to the development of the society. It has been a long day, but I would like to thank many, especially Manish Deet and team. Uttam Kalwane Saab, let's give you a big round of applause for the effort they have put in. Thanks to Munish Sharma ji for making this all these arrangements ready on time and handing over to us. So it was great. And the only complaint I may have is that I have gained 2 kgs of weight. They were providing such a wonderful food that I don't know how many days it will take for me to get it down. So thank you for the wonderful food which you have given to us. Again, we had the presence of our ISSMG Vice President Albert KG, and is officially called in close circle, we call him Albert with us. And he was here, he shared his knowledge, and he's a great expert in the world in the field of trenchless technology. So thank you, Albert, for sharing your valuable wisdom to us in this. Today, we have our own, Guru Vikas Ramgude sir with us, who will be sharing his experience and expertise as the Joint Managing Director of MICDC Mumbai. So sir, look forward for hearing your valuable knowledge and sharing this. So here we have seen that we had a wide spectrum of points discussed, about 461 paper, and this time, the first time I am seeing that there are 13 parallel sessions happening simultaneously. Again, congratulations to the organizers and Jaiswal in particular for coordinating everything. It's not an easy task to plan everything to 13 parallel. Recently, I had the interaction with IEEE National President, and he was telling that when we do the conference, we have 12 parallel sessions, and I was wondering. Next time, when I'm going to meet him, I'm very proud to say that in Aurangabad, we did 13 parallel sessions. So wonderful job being done. Set the benchmark up. So I can see that every year, the standard of the Indian Geotechnical Conference, standard of our festival of geotechnical people who are deciding, who we are buried below the ground, deciding on the nature of the ground, is improving every year. So next time, I know in NIT Jalandhar, the team is here, Agnihotri sir and team, they are ready to take us to Jalandhar next time, and again, then to Maji and team will take us in 2026 to IIT Chennai, where they will be hosting that. And I am sure that soon we are going to break the 1,000 registration number barrier, and we will need bigger and bigger halls like this. So thank you all for coming together, keeping these journeys. And I always believe that success happens when we come together, keep together, and work together. That is where the difference is going to make. Let us be together and make sure that we are making safe and sound structure, which is very much necessary for the development of our country. Thank you all once again.
Thank you very much, sir. Now I invite chief guest of today's valedictory program, Mr. Vikas Ramgude, Joint Managing Director, MSIDC Mumbai, to address the audience. Thank you very much.
Good afternoon all. The dignitaries on the dais, Dr. Joseph sir, Singh sir, Albert ji, Sharma ji, Kalone sir, and the man behind this conference, Manish Dixit sir, the stalwarts of the dais, Dr. Chaudhary sir, Vishwanathan sir, and the abutment of Indian Dr. Samadhiya sir, and the abutment of Indian Geotechnical Society, Ramesh Kulkarni sir, and dear friends. Uh, I will not speak much about this because there are so many learned and the wise people who have spoken about the say research, academics, and the various new products, their applications, and there are also few many executors. They have put their views. So I think there is nothing remaining for me to speak about. And again, as per Mark Twain, it is very difficult to take the session. I was professor for 4.5 years. So taking session after lunch and when people are ready to leave is again difficult tasks. So I will conclude, I will conclude my speech with a very few remarks. What I am seeing that whenever we praise the Taj Mahal, we forget to geotechnical engineers who have designed foundation in such a beautiful manner that the beauty of Taj Mahal is remaining intact because of that. So day by day, civil engineering is the discipline is obligatory discipline or majburi ka naam civil engineering अशा इस प्रकार से हो रहा है. So I say take the pride that all the permanent structures and the glorious structures are built by we civil engineers, because that's why there is a different branches, but we have given the title of civil engineer, that is most civilized people, what we call. And we have a very long background of say basic history. And today the India is just passing through its Amrut Kal and 75 years, and we have the fastest say rate of infrastructure development within last 15 years. And the rate of growth of development of infrastructure has reached to 4 to 5 times the what was in the 2005 or something like that. Again with the fastness, what the Martin Luther King said once, that if you are sitting, try to walk, and if you are walking, try to run. Again there is a, so in terms of Mark Twain, that if you are running, where you have to go, that you have to first decide. So only fastness is not the matter of quality. We have to always go with the quality, durability, strength, stability, and finally the word which is included in the say, subject list, that is the sustainability of your infrastructure. So it is utmost important that you should have these sustainable structures, because you are not dealing with somebody's personal money, it is the public's money or it is the people's money at the work. So you should be much careful about this. As far as Maharashtra is concerned, there are so many agencies working on infrastructure, just like NHI, MRTH, MSRDC, our own MSIDC, Metro, Maharashtra Metro Rail Corporations, and state PWDs, WRDs, other energy departments, so many local municipal corporations and councils. So, so many agencies are working and they are trying hard to get us from developing countries to developed countries. So, here the coordination among these organizations is utmost important. Again, the infrastructure, the quantum has increased to 4 to 5 times, but again there is a issue of the skills. So even from the laborer to the experts, the skills are lacking. They are not up to the mark as far as quantity and qualities are concerned. So it is our great responsibility that we should try to enhance these skills, because after all the quality will be only with the skills. Quality is never an accident. It is always outcome of sincere and intelligent efforts. And there must be will to produce superior and economical thing. So I congratulate this Indian Geotechnical chapter of Sambhajinagar and the basically MIT for arranging 2 successive grand events, that is Young Geotechnical Engineers Conference and this very beautiful and grand conference, that too in Sambhajinagar, with this, even though the Indian Geotechnical chapter of Sambhajinagar is in its youth stage. They have taken this Hercules task and they have lifted the Shiv Dhanusha, one of these most successful conference, and with such auspicious gathering. I am very thankful to them for inviting me to give few words to them. And just like what the Vinoba said, I am just the apprentice of geotechnical engineering. there are masters of geotechnical engineering. Beyond that, there are experts of geotechnical engineering. There are masters of geotechnical engineering, and the very few are the persons who have obtained the wisdom in geotechnical engineering. So we all, and again, one point what I try to mention, there are so many professional organizations, but I am also member of nearly say 6 to 7 professional institutes, but this is the most harmonious and a very family-like organization what the Indian Geotechnical Society is. So when you are always with them, it is always feeling homely. And our people say that why you are going there and at this age what you are going to learn. So I think if I may not be wise or I may not at this age, I may not become I may not have the light of wisdom, but it is better to at least remain with the people who have the wisdom. So that सभी कुछ अंधेरा नहीं है, उजाला कहीं तो कहीं ना कहीं है. इसकी जो हमें बेसिकली इसकी जो इंस्पिरेशन मिलती रहेगी, and this will give you the hope that this country will developing in infrastructure with quality structures. So finally I will say that we are all committed to develop the modern India, just like the Nehru said, the dams are the temples of modern India, and only China Wall was the structure which was seen from the Mars or from the moons or something like that. But even Pune, Mumbai, the Nagpur, Mumbai, Samruddhi Mahamarg, and so many structures, they are now visible from the space, and we have to create our own space as an Indian among the world, as a qualitative country. And I again say I am thankful to organizers for calling me, and I am also thankful to you for listening my say few words. Thank you very much.
Geo Vishleshna 2024 second prize winner. He had some problem in reaching this place, but he has arrived. So I will invite him. This award goes to Mr. Dev Yadav and Sneh Rao Saheb Pajal. So I invite them to come on the stage and take the award. Yeah, come forward.
Please.
So I have a small announcement to make. Such a wonderful contribution has given by MIT, and there is another surprise. Professor Munish Sharma has came up to constitute an annual award for IGS MIT CSN Outstanding Young Geotechnical Engineer Award, and they will be contributing cash of 25,000 every year. Thank you very much for the great gesture. We will take up with the EC and get it done. Thank you. So a big round of applause for the big heart.
Thank you very much, sir. I would like to thank the chief guest of this function for the encouraging and the words of appreciation. Now we have to come up the brief presentation about IGS 2025 by IGS Jalandhar team, Dr. Rupali Satavlekar. Yes, ma'am, please.
Honorable Chief Guest of the event and President, President IGS, Shri Anil Joseph ji, and Secretary IGS, Dr. AP Singh ji, dignitaries on the dais, of the dais, my dear colleagues, research scholars from different parts of the country, ladies and gentlemen, very good afternoon to all of you. Myself, Professor Arvind Agnihotri. I am professor in the Department of Civil Engineering at NIT Jalandhar, and also I am chairman of IGS Jalandhar chapter. First of all, I am thankful to EC members of IGS, particularly President Shri Anil Joseph ji and Secretary Dr. AP Singh ji for giving us this opportunity to organize IGC 2025 at NIT Jalandhar. If I give you brief about NIT Jalandhar, it was established in the year 1987 as Regional Engineering College. Then it was upgraded to the national level, NIT Jalandhar, in the year 2002. At the moment, we are offering 14 BTech programs in different disciplines and more than 20 master MTech programs, MSc programs, MBA programs, and PhD programs in all the disciplines. You can see the beautiful campus where you are about to come next time, during the same days. Dates are 18th to 20th of December 2025. Jalandhar city is well connected by air, by road, and by rail. Approximately 350 kilometers from Delhi, and it is connected by rail also. By air, nearest airport is Amritsar Airport, about 1.5 hours away from NIT Jalandhar. And also Shatabdi Express, morning, evening Shatabdi comes to Jalandhar, and bus service, very good bus service, that is also available. I assure you that you will enjoy both technical sessions as well as some cultural programs there at NIT Jalandhar. Already I am delighted to again recall the announcement which was made at the time of inauguration that annual lecture speaker has already been announced, Professor Dipankar Chaudhary. So he needs no introduction. He is renowned and eminent geotechnical engineer. Also, we will arrange 10 to 12 keynote speakers from different parts of India as well as from abroad. Similarly, theme speakers, 15 to 20 theme speakers we will arrange from different parts of India as well as from abroad. Young geotechnical engineers we will invite so that our young researchers, they should have very good connections, very good interaction with them so that they can establish some ties with them for their future research. We will have pre-conference workshop also. In pre-conference workshop, that will also be of international standard. We will invite some people from different parts of the world, renowned persons for this conference that will be on 17th of December. So I invite all of you along with your spouse and also with your other colleagues. Please disseminate this information with amongst your research scholars, your colleagues, so that more and more people, they should join and they should visit NIT Jalandhar next time during December 18th to 20th, rather 17th to 20th, pre-conference workshop, that like international workshop, that will also be arranged on 17th. So I invite all of you to NIT Jalandhar next year during 17th to 20th of December 2025. Thank you so much. If you can see some facilities here, we have look for central seminar hall where our inauguration will take place. Very adjacent to this, we have new lecture theatre complex where all sessions will be arranged. Adjacent to that, we have student activity center where refreshments and foods and everything that will be within 1 minute walk. Everything will be available. You will feel comfortable. Other, if you see, show the next slide. Next, these are some hotels. Some of the hotels we have shown here. Website has already been developed. IGS 2025 nitj.com. So all information will be available in that website. Some names of the hotels we have mentioned here. We will talk to other hotels also, and list will be provided on the website with concessional rates. Next. So these are some places in and around Jalandhar. Siddh Shakti Peeth Devi Talab Mandir is there in Jalandhar. And we have Jange Azadi Memorial. We have Pushpa Gujaral Science City. And to have some idea about Punjab culture, there is Rangla Punjab, where you will enjoy. Next, please. Then in Amritsar, we have Golden Temple, world famous Golden Temple. Bagha border parade, that is very important. Everybody wants to visit that. Jallianwala Bagh, then Durgyana Temple. These are some of the attractions to the tourists who visit Jalandhar and Amritsar. So with these words, I again invite each one of you to IGC 2025. Thank you.
Thank you very much for the beautiful introduction of IGC 2025. Now, I feel great to announce that the awards of this conference are already ready, and they will be shortly shared through email to all the participants and all those who are related to this conference. So congratulations to all the winners. Per theme, there are 2 awards, which will, the names of the awardees will be shared through the email. Now, I invite the participants to share their views, if any, suggestions, comments about the conference. So, I would request the participants to come up on the dais and share their views. Thank you.
A very good evening to all of you. Actually, the IGC 2024 was awarded to Ahmedabad chapter at that time. I was the president. And executive committee, some of the executive committee, they have some doubts whether this hall will be ready or not. Because when we came here, there was construction going on, and there were some problems also at that time, I don't know. But under the leadership of the director of MIT, now we are sitting in this beautiful hall. So let us give a big hand to all the officials, not only director, all the officials. Then another thing is, this was the first time, at that time, the IGS Executive Committee thought of giving the prestigious IGC conference to a center which just started. At that time, it was 2.5 years only. Now it is 5 years. So, but whatever doubts we were having, now you can see they have organized in such a manner that everybody is praising for that. So let us give big hand to the organizing committee. I would not like to name, because when we say organizing committee, there are many others which are also responsible. So under the leadership of the chairman and the secretary of IGS. And the arrangements they have made, especially for accommodation and for transportation. Everybody has been accommodated, and they have arranged taxis and also the buses so that everybody is comfortable. Everybody. And also, we have enjoyed the nice food, especially of this particular area. I hope you must have enjoyed bajra ki roti and also jowar ki roti in this particular time. Now, as far as the technical contents are concerned, you can see that they have already reviewed the papers by 2 reviewers, which is the requirement of the Springer. So all the proceedings, the selected papers, I'm sure that some of the papers which have been presented or which have been submitted might not be part of the final proceedings, because there is a strict policy and we have to follow that policy given by Springer. So, but they have assured that maybe by June or maybe July, you will be having those proceeding volumes, and volume are in big number, 10 volumes they are going to. I am very happy, and you can, because most beneficial from this conference, although the work which has been done in the past, is Samadhiya. We have given this responsibility to chapter, Aurangabad chapter, and they have organized such a beautiful conference. There are many awards which are given, and you will find mostly majority of the awards are given to Roorkee people. Whether it is IGS Roorkee chapter, or the faculty of the Roorkee, or the teachers of the Roorkee. So we are directly or indirectly connected. And as I said, I should be given the best PhD examiner also. So indirectly, I have evaluated those theses for which 5 students have got the award. So it means my evaluation is okay. So I will not take much of the time. And Dr. Anil Joseph, he would like to felicitate all the members. So thank you very much for organizing such a beautiful conference. And I'm sure every one of you would like to come again to MIT Aurangabad. Thank you so much.
Thank you very much for the words of appreciation, sir. Now we have almost come to the end of this uh, valedictory program. Before I call upon Dr. Manish Dikshit, the organizing secretary of this conference, I would like to let you know that I would request the participants to be seated. The vote of thanks will be followed by the very own tradition of Maharashtra, Pasaidan, the verses by Sant Naneshwar, followed by national anthem. So now I request Dr. Manish Dikshit to express the vote of thanks.
Good afternoon to one and all. This is the last session, that is the validity session of IGC 2024. The chief guest of today's function, Engineer Vikas Ramgude sir, Joint Managing Director, MSIDC, Guest of Honor, Arun Agarwal, Director, Kalika Steel, Dr. Anil Joseph, President, IGS, Dr. AP Singh, Secretary, IGS, then Professor Albert Shahu from ISMGE, Vice President, Professor Munish Sharma, Director, MIT Group of Institutes, Dr. Nilesh Patil, Director, MIT, Dr. Y. Kaude sir, President, GS Mandals, Dr. Uttam Kalwane, Chairman, IGS Aurangabad Chapter, all EC members of IGS, faculty members, and my friends. Good afternoon to one and all present here. We, at the validity function, are hereby summarize the few things regarding the IGC 2024. The 46th annual lecture delivered by Professor BVS Vishwanathan sir, 12 keynote and 16 theme speakers were presented successfully in this conference. We have full-length paper presented 452. Out of 461, we are having 452 presented. All the papers will be published as a book chapter in Springer Nature. 10 volumes will be published, and there will be a separate issue of Indian Geotechnical Journal for keynote and theme speakers. So out of 28 keynote and theme speakers, already we have received in the Indian Geotechnical Journal 20, I think, papers we got. 8 papers are still pending, but within 8 days, that will be also included in that. And review process will be followed, especially for the Indian Geotechnical Journal for keynote and theme speakers. We have all in 13 parallel sessions every day. So in these 3 days, we are nearly about 54 parallel sessions all for 16 themes, and which has been completed successfully. It was a tough job for me and my team. We come across many hurdles, speed breakers during this work and during the conferences. So each hurdles and speed breakers we have successfully defended by me and my team. Organizing the conference is I think it is a difficult task, but we have done it successfully by all the team members. My special thanks to Ramesh Kulkarni sir, who has always guided me whenever I found it difficult. Entire IGS Pune team for the invaluable support and cooperation for this conference. My special thanks to Professor Nilima Madam, Dr. AP Singh, Dr. Anil Joseph for the support they have given for IGC 2024, and every time they have supported me, starting from 2019 with the start of this chapter. Also Professor Samadhiya sir, who was here for all the 3 EC meetings also. And under his guidance, we received this IGC 2024 conference to be held at Aurangabad. Finally, this conference, IGC 2024, has enlightened and boosted the knowledge and skill of all researchers and students. Finally, I would like to take this opportunity to thank all the members of the organizing committee, advisory committee, keynote, theme speakers, reviewers for their dedication and contribution in the conference. Without their tireless work, this conference would not be a success. I thank all the sponsors for sponsoring the IGC 2024. I also thank Ma Advertisement from Nasik for the design of all IGC 2024 souvenir, printing, leaflet, and printing press of Sakal, Nasik, who has brought this 46th annual lecture and souvenir in time. Also thank to the web developer Digital Marketing Nasik for the IGC 2024 website. I also thank Ms. Ritika Madam from Stranger Nature for bringing the IGC 2024 book cover within a short time under the theme Ground Improvement Techniques. I also thank Mr. Devanand Sanap, Event Management. Thanks to Ayojan Caters for the wonderful food arrangement for all of us. Thanks to all my team members who has worked hard for the success of IGC 2024. Lastly, I acknowledge the support given by Director General Professor Munish Sharma, MIT Group of Institutions, Director Professor Nilesh Patil for their much needed support. Thanks to one and all. Thank you.
Now we will felicitate to Chairman and Secretary of the IGC.
Thank you very much, sir. Now we will have Pasaidan. After the Pasaidan and National Anthem, there will be a group photo of organizing team and volunteers. So all are requested to gather on the dais for the same. I would request everyone to join hands and close eyes because this prayer by Sant Naneshwar is nothing but a prayer for well-being of this entire existence. So let us together pray for the peace and happiness of this entire existence. आता विश्वात्मके देवे येणे वाग्यज्ञे तोषावे तोषो निमज द्यावे पसाय दान हे जे खळांची व्यंकटी सांडो तया सत्कर्मी रती वाढो भूता परस्परे पडो मैत्र जीवांचे दुरितांचे तिमिर जाओ विश्वस्वधर्म सूर्ये पाहो जो जे वांछिल तो ते लाहो प्राणी जात वर्षत सकळ मंगळी ईश्वर निष्ठांची मांदियाळी अनवरत भूमंडळी भेट तू चला कल्पतरूंचे आरव, चेतना चिंतामणीचे गाव, बोलते जे अर्णव पियुषांचे, चंद्रमेचे अलांछन, मार्तंड जे तापहीन, ते सर्वाहि सदा सज्जन, सोय रे हो तू, किंबहुना सर्वसुखी पूर्ण हो नीतिहि लोकी, भजिजो आदिपुरुखी अखंडित, आणि ग्रंथोपजीविये विशेषी लोकीये, दृष्टादृष्ट विजय हो आवेजी, येथ म्हणे श्री विश्वेश्वरावो, हा होईल दान पसावो, येणे वरे ज्ञान देवो, सुखिया झाला, सुखिया झाला, सुखिया झाला. ओम शांती शांती शांती. हरि Om. Thank you very much. Now I request everyone to stand up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष मागे, गाहे तव जय गाथा, जनगण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे, जय 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 हे.
भारत माता की, भारत माता की, भारत माता की. Thank you everyone. I request the organizing committee and the student volunteers to come up on the dais for the group photograph. Also, I would like every participant to know there is arrangement for dinner at 7 p.m. in the evening. I would request everyone to enjoy the dinner with all the participants. Thank you.